right, there we go. How's it going? Willow left immediately once I hit start streaming. She was sleeping under the desk, being cute, and then she left. She didn't even move into the main area there. She's probably in front of the couch in the other room. I need to set up some dedicated Willow cams because she has not had any presence on my show in a month because she doesn't like the noise of me streaming. And I need to emote more. I need to be more animated and active. I know, it's like when I hit the button, the network traffic alerts her or something, and then she leaves. I wasn't even being loud. I wasn't even being loud. I'm being loud now, so I can fully understand, but I wasn't being loud then. And she just leaves. She knows that I'm going to be here yelling at the furniture. I did all my titles. I don't think I forgot anybody there. I updated both YouTube and Twitch. I think that's all sorted out. I haven't done a gaming stream in a long time. The stuff that I'm currently uploading is from when I did a week of gaming back in, what was it, December of 2021? And it was actually no, it wasn't November. No, it was November. In November of 2021. I'm still uploading. I just barely got into December, but when I took a break and then a vacation, I took a break for a week and I did My Summer Car primarily streams, which was really fun. Those streams are so easy to upload because all of the different things that happen that I have to mark down, because you can mark chapters, right? And it's nicer for... Ever play Factorio? Yeah, that game renders... it's a time machine. It's a time machine that only goes forwards, but it is a time machine. Factorio is a lot of fun. My favorite Factorio moment was when I was playing at a LAN party with my friends, and I was just goofing around, right? Because they were the ones that have this like glorious plan of exactly how they play Factorio, which is to pave over everything, right? You turn everything into glorious concrete for the motherland. But I was just kind of goofing around and helping out where it counted. I built myself a pair of night vision goggles, so I was able to see at night better. It was awesome, except we didn't have batteries yet, so I made solar-powered night vision goggles so that in the evening I could see perfectly, and in the morning I could see perfectly, dawn and dusk. During night, they powered off, and I wasn't able to see anything at all. So I thought that was a hilarious use of night vision. Hold on, I'm gonna cough. I just wolfed down like a chicken bowl thing. The music that I'm playing right now that only Twitch can hear and the VODs cannot is OTT. Because I've been on kind of an OTT binge. I like OTT a lot. They do have a Twitch channel, but nobody knows about it. And I subscribed to their Twitch channel, but they streamed once for about 25 to 30 seconds. Once. And it was a picture, it was a 3D printer, which was pretty awesome. But yeah, I played My Summer Car during that, and I haven't uploaded the stream yet, but the stream where for about 2 hours, I am looking for how to wire the starter motor. Because I got the positive lead of the starter motor, but the negative lead is a bitch to figure out. It's tough. And it follows car logic, but there's sort of a schism in My Summer Car, because some things follow My Summer Car logic, some things follow game logic, and other things follow actual car logic. So if you were actually working on a car, you'd be like, oh, clearly you grounded the motor, right? And so you would be looking for like a ground lug, or where a ground lug goes. In the game, you're like, well, what is Topless Gun, the programmer of the game, doing to kind of screw me over here? What is this trick? And I was very adamant, and Fatanon did a really good job of moderating chat so that I didn't get any answers. Because some people, I think when I finally figured it out, it was because somebody like let slip a clue that was a little bit too on the nose, which I'm annoyed with, because I wanted to figure that out on my own, but I got to a point where I wasn't able to. I got to the point where I was even just thinking about, what would Topless Gun do in this scenario? What would be the worst thing that you could possibly do? And spoilers for My Summer Car, which everybody should have already played, It's that the ground lead bolts to the crankcase. And I even looked to see if that was the case, and I did the wrong bolt. It has to be a specific bolt, which is exactly what I thought Topless Gun would do, but I didn't follow through and check multiples. I'm going to fix my mic. I think it's in a weird position right now. Hold on. I'm using the button adapter for this Tram TR whatever, but I probably should be using the clip, because the clip holds my shirt in just the right position. Let me go get a spare clip. I'm reserving the other clip for when Julian's here, because he likes to use that. Give me one sec. Oh, in terms of emergent gameplay, a la a car-related game, My Summer Car is on just a level of its own. You should play that game. It's a little bit of a chill game. It's a little bit of a tough survival game. You will have an amazing amount of fun figuring it out. Even for like it is relatively old at this point, but like it's amazing. It's absolutely in like a category of its own. I would suggest you play it. Strongly suggest, actually. I bought a pack of microphone adapters. See if that works. Yeah, it can't. My Summer Car cannot get more of a glowing recommendation from me. There's no level of praise higher than what I give it. I think it might be one of my favorite games of all time, and I think a lot of people would agree with me on that one. All right, so in order to fix mic stuff, I bought just a ton of these little mic clips. Problem is, my mic is square. These are rounded. So how do I make up for that? I'm thinking just shove the mic in there, and it'll be okay. We're back, baby. That's pretty good. That holds it off, and the clip makes sure that it is in the right spot on my chest. Hopefully it doesn't sound like I'm like under a pillow or in the next room talking to you. This should sound crisp and clear and like I'm right here. Yeah, a 3D print would be the way to go, because it's actually not difficult to 3D print a little square prong on this thing. These are useless. Don't use these. Pop filters. You should have good mic discipline instead of a pop filter. These are just useless pieces of foam. Maybe if you're in high winds, but in that case, you should get a special windsock. What mic? It's the Tram TR50. It is a movie quality or a TV show quality microphone. You can go crazy with lav mics. You can buy thousands of dollars of lav mic, but to get good audio, I mean, this is only like $150. Is it TR? TA. Tram TR50. If you buy it new, it's going to be a shocking price. This one's square, which makes it kind of nice to tape to people. But it's got a very nice response. It gets a little crazy with the high frequencies, which is why I run it through a 7-point EQ. Well, 5. There's 5 visible points. I guess I have others available, but I am adjusting that to be like this. And I've gone through this a couple times. I still need to probably tweak it a little bit. But you can get an inline adapter for it, which is something that I probably should have done. I designed my own circuit in order to make the microphone preamp, and you know, honestly, I would love to do something after the preamp before it gets to my audio thing over here that would compress and equalize it, and I would love to do something with a vacuum tube, just because that's fun and it offers like a warmer sound, even though I've got pretty warm sound right now from the EQ. If you actually try to buy one, the price will explode your brain. Boom, your brain is exploded. But if you go to a place that rents mics, much, look at that, and you even get the transformer. That's $50 I could spend and have oh bother quality audio. But you do want to EQ and compress your lavalier mics, because they pick up everything. This microphone will pick up. I plugged it in when I first got it, and I was used to having a cardioid mic, like something that picks up a lot, but you have to be in the sweet spot. And then I clip the thing on and I plug it in, and I was like, what does this sound like? And I heard it was ridiculous. Yeah, I think Tomato uses some kind of a movie quality shotgun mic. It's an AT2020 USB is what I used to use, and I used to use it without filters, which is a mistake, because like if you are a shouty person like a streamer, then it will get loud, because it picks up everything. You want to compress that audio so that you can shout. I probably should uncompress a little bit of the shoutiness sometimes. What up, Walrus? How you doing? It's the Walrus. Oh, I don't have social stream whatever open. Gotta open that. That's the wrong one. Which is the one that I want? I want that one. There we go. Now I can actually see all of my chats, both in YouTube and Twitch. But yeah, this microphone, I didn't buy it. I bought my backup one. I bought the backup microphone, but the microphone that I use is given to me by my buddy in New York City, Joe, who does professional audio. He has his whole audio. I think he sold most of his audio card. I don't really know what he does now. I should talk to him. I should call her. I should call him. But yeah, he does like professional movie audio, which is not movie, TV show. He had a couple TV show gigs recently. But yeah, he was like, yeah, I got a spare lavalier if you want to try it out. And he sends it to me, and I'm like, holy shit, I owe you everything. Yeah, AT2020 is a cardioid condenser mic. Somebody back in the day wondered what my sound setup was, and what people don't realize is it's not so much the equipment that I use. The equipment that I use, I have upgraded, because I mean, you guys literally paid Twitch to pay me for it. So that money I love putting back into the production quality of the stream. I don't think I'm going to go 4K though anytime soon, unless Twitch completely supports it. We'll have to see where that goes. But yeah, 90% of audio is post-processing. The equipment is not that important. You get something for $100. If you actually get a microphone that's worth $100, like an AT2020 or one of those others, it's the post-processing that will give you the best quality. And this takes work. You have to do the work. You have to sit there and you have to listen to yourself talking. And I could probably do this live, but what I do is I run it, because these plugins are in OBS, which I don't like them being in OBS, but they are in OBS. I will one day figure out how to get myself away from VST plugins. These are old. I haven't upgraded. I haven't updated the software either. But this M Audio stuff is free. They run as VSTs on the audio source in OBS, and they filter out all of the nonsense that the microphone would pick up, and they tweak and tune it to my voice I hit record on OBS, the little record button that they have. I can't show you it. This monitor's, the window's too big. But the record button on OBS, and I said the same phrase every single time and watched the video. And that way I was removed from having a delay on audio. And I basically said the same thing and just went through the, what do you call it? Went through the bands from low to high, and tweaked it to a point, listened to it, tweaked it again, listened, tweaked again. I've done a little bit more in the recent past to try to open it up a little bit, make it not sound like I'm talking to you guys from under a duvet. But yeah, it's work. It takes a lot of work. Finding out, you know, what the good boost on me talking quietly versus me shouting, all that stuff. It's work. I gotta do work. Why did the Social Stream Ninja not work? I don't see chats in there. Hold on, I'm gonna do a little, go over to here and do like test. I was looking at Reaper, but I didn't like how it worked. Live broadcasting is a totally different animal. Yeah, that's not coming up over here. Which, it must be the wrong URL. Social Security, that's exactly what I'm looking for. Reload maybe? Audio engineering. Yeah, it is a pain in the butt, and those plugins that use graphics cards are doing a pretty good job. Web pages. 1, 2, 3. Oh my god, there's all of that. So now I gotta close it again because I'm probably getting echo from this one. Close that. I got it before it loaded. There's my social stream blade. There we go. Now they're showing up. This one is just a monitor window. The one that goes into OBS is doing its thing. The problem is like everything is, even though, you know, you have your audio workstation that's typically made to do like making a song or you know, recording a YouTube video or recording a podcast is the big one apparently. The mixer that I use, as suggested by Tomato talking about his gear because he has really good audio, is the Rodecaster, but that's made for streaming. It's made to have a memory card put in it, and it's only recently been getting software updates to make it a little bit better for us lowly streamers. We're not all about recording what we do. We are about broadcasting, and it's just so different. I've looked at a couple different audio workstations, like Ableton Live is called Ableton Live. It's called Ableton Live. Live is in the name. But it doesn't work out for doing audio workstation stuff here. Like it can only listen to one source. Julian came in and he was confused too because I have the Focusrite 2i2, which is an input, like an audio input. I have a new one and an old one, and he was like, you can only have one at a time because those are the tools that he uses, right? But I can plug in tons of audio sources and have OBS pointed to them, all of them. So I can have 4 channels coming into here. Although the Focusrite should be the last piece in all of this. It really should, because it's got all the good monitors and stuff like that. But I need to do some revision on the audio stuff. I need to get these lavalier microphones to be able to go directly into the Rodecaster. But the Rodecaster doesn't allow me to have individual channels. Ableton is garbage, even if you're competent at audio. We used Ableton to do the fire cannons. We did the piano roll in order to make the fire cannons. Boop, 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 boop. A lot of artists use Ableton in conjunction with their physical art stuff. There was a guy who did the, oh God, what was it called? It's that type of like monk-y kind of orchestra where they've got like, you like do a brush on like a cymbal or you hit a drum and, oh, it's on the tip of my tongue. But he would put it in a dome and he controlled all of the individual like instruments with servos and stuff all through Ableton. So he's able to make like a song in Ableton that would just play ambient. It was a great tent to just fall asleep in during the day because you were surrounded by instruments playing a chill tune. Which, like my message so much, it did it twice. So are we at that point? Really, only getting better after it got sunset and then Rode decided they wanted to support Linux. Well, I have the Rodecaster Pro because you guys paid for it. Really expensive. Gamelatron. That's the Gamelatron. Hold on a sec. I don't know. I don't know which one is it. Yeah, Gamelatron came to one of the festivals that we were working at. But it's they put it in like a dome, and it just plays this like ambient stuff. Pretty cool. I talked to this guy for a while about Ableton. And see, it just plays. It's crazy because you're surrounded by the instrument. I guess he's selling them to people. Weird. Technology. Pretty cool stuff. $1.2K for the production level Ableton version that offers only 8+ channels. Jeez. Yeah, it's really cool. I mean, it's like, it's just imagine going over to somebody's house and you're like surrounded by instruments that every now and then make a cool noise. Like, what is going on here? It is trance-inducing is what it is. It'll put you into a trance. Look at my sloppy heat left over from my arm being on the desk. What is wrong with this guy? Is he stupid? All right. Yeah, there would be no audio for that on YouTube, so apologies. You guys can open up that YouTube video and take a look at it, but it is unfortunately not broadcast. Mostly specifically because I would get copy struck from it. What are we looking at? Let's see, I gotta reload that. That's the last thing that happened here was McBobbles for 5 months. Did I give Syphilate and McBobbles a shout when they subbed? I know I said Speedy Cat gifting to Flatulent Gonad, and then Flatulent Gonad shouted me out during his during his stream, which was cool. My brain was dead last night. I uploaded 8 videos on Wednesday, and so I took a night off from uploading videos, but I gotta get back to it because we still have 282 to go. 282 videos. That's a lot of me time. It's a lot of time because it takes me like 15, well, maybe like 10 minutes per video, but it's not that cut and dry. I need to hit the right arrow key and look at the entire video to see what's happening. It's now $599. I'm not even interested in that stuff. You are such a gear hound for your expensive things. And I'm not interested in spending a buttload of money. But I am interested in figuring out a... what's that? Not the work part. The chilling in someone's stream. Oh yeah. So like, I don't know. The gear that I have is not terribly expensive in comparison to other studio gear. It would be pretty bush league actually, pretty cheap. But I've gotten pretty far with what I have. I just need a couple things to kind of tie the room together. And the thought is having discussions with fellow streamers that everything should probably go to network stuff, NDI and maybe AudioNet, and that might alleviate some of my gear issues and mixing and routing issues. Wonder if I can get the rubber off of these, because these are dead. These rims are dead. They're bent. I bent them in a high-speed accident, which involved the RC car daring to touch a rock, the suspension unable to do a damn thing, and then the car flipping out and hitting up against the curb. 2 of the wheels are completely bent. The high-end zone of audio over Ethernet. Well, the stuff that I know, the Aviom stuff, is apparently not that current. I would have loved to use that stuff, but yeah, whoops. You know, I was doing like a high-speed pass and I was going to record it, and it just went, yoop, just fucking like flipped out and exploded. So, and these are metal. The audacity. I don't know if you can get the tires off after they've been glued. I'm going to try during the intro here. Let me just peel them off. What deactivates superglues? Heat, right? And heating up rubber is probably not a great idea. You need like a lot of heat. It's crazy. All the audio tools that I've looked at just don't work for me. Yeah, I don't think acetone would like this rubber very much, huh? Well, they're glued to metal, so the metal should not be very sticky. And it seems like it is coming off. Maybe use the pin tool to help. Need to make a tool to do this. The de-tirizer. A friend of mine did that when gas-powered RC cars came out. Paid a bunch for it, decked it out, made it look sweet, did a high-speed pass, clipped a pebble, took out a mailbox, and the car's no more. I think short lurkers had a propensity to be linking these high-speed RC cars blowing up into a billion pieces. Yeah, that's just a risk you take, which is why I do like the 1/24th scale, because it's not a super expensive. I mean, it's still costs, but it's not a debilitating amount of money to get it back on the road. But what we're doing today is hopefully making inroads in making this car a little bit more durable, taking all the wires out of the equation. Because I hardwire things. Generally in RC, what you're doing is running connectors for everything, because you want to be able to swap stuff out. You do connectors, you tape everything, you put shrink wrap on it. A moist, warm towel laid over the product. What? What? A moist towel? You know, because that's as aggressive as they're allowed to go. They can't say run it under hot water, because somebody will burn themselves and sue. They can say, just be careful out there and make sure to wear a helmet when you pour slightly perturbed water molecules over this glue. Over the most aggressive glue known to mankind. Actually, I'm sure there are more aggressive glues. I mean, if warmth is enough, then I can run the hot air gun on these and maybe break it off. Or just do this. This seems to be doing something. I'm just running it against the metal so that it cracks the glue. Or removes a layer of rubber. God, that is tough to do. The gel stuff doesn't like to stick to skin. I've tried to suture wounds before with it, and it just falls off after a little bit. Jeez. I might be able to rescue the tires. I'm not totally certain about it. Yeah, that one's pretty damaged, actually. I don't know. If that's the inside rim, then maybe it'll work out. Not out of album, are we? Now we're in the middle of OTT mirror. I'm trying to... Moisture helps with lowering the heat required. Huh. I don't know, like super glue versus warm water. I can't believe it. Find it hard to believe. But if that's what they say, that's what they say. Try to like scrape that. Nah, not really working out. It's good that I do have an extra set, but the metal helps for grip on lower speeds because they're heavier. I've seen for the rock crawlers, they have weights in the wheels. They actually have wheel weights that you buy. Put them in there. Generally with vehicles, you're trying to lower the unsprung weight. But, oh God, my thumbs are getting tired from this. My thumbs is tired. Give me this. Ah! I wonder if I ran them under hot water, if that would help. I mean, I think generally Loctite super glue would be getting people asking them how to remove the glue because of an emergency situation. Olive oil or a 2-to-1 mix of water and white vinegar? Huh. I mean, I could hit it with the goof off rather. See if that'll do anything, but it'll probably start dissolving the rubber pretty quickly. The problem is I don't want to walk over to the bathroom and use the sink in order to run it under warm water and see if I can get it off. I can go try it if you guys promise not to ruin the stream. Don't like use the stove while I'm gone. Hold on. Let me do a BRB and I'll try some hot water. Try running it under hot water and see if this works. Overlays, do a BRB. No, don't do it. Don't use the stove while I'm gone, okay? I'll be back in just a second. Candy creams, hot buttered ice cream. First you get the butter, then you make it hot. All right, these are pretty warm now. Ran them under hot water for just a minute. I mean, I'm hearing stuff. Rubber's actually harder to work with right now. What the heck? Yeah, cyanoacrylate. It's the particular brand that I use is Loctite. And their cyanoacrylate, it's like a gel. Oh yeah, BRB. Dude. With those on top of one another, I need to move it for that scene. It is, I do hear like crackling, and it is kind of giving up in some spots. Others, the rubber's ripping for others. So I don't know if that one survived so well. It's okay. I mean, I would use it in a pinch, but yeah, it's kind of hurting it a little bit. Yeah, I don't know. Like a certain amount of heat will undo it, but I don't know. Let's try more heat. More heat, I say. We're gonna get to fusioning in a bit. Fusion 360ing, spinning around in place. I don't know how to do the physical model stuff. I was watching that ClickSpring video a minute ago. His latest from the Patreon, which has, well, I don't know if it's his latest. I'm not part of his Patreon, but his latest thing was a dial indicator project, and he had like full motion on his CAD. Rubbing alcohol. You think that'll work? I've got a can of it literally right here. This is my rubbing alcohol canister. I filled it up with rubbing alcohol to the line, and then I put a bunch of compressed air in there, and it's been actually a really good alcohol sprayer for quite some time. The fact counts as the manual. Sure. Forceps. Forceps. Of course, if it's too hot for me to touch, then I can't peel the rubber off. Yeah, it's great for cleaning stuff off, Mr. Yan. It's really good to have, you know, be able to buy rubbing alcohol by the bushel and then just putting it in your own container. Because I can absolutely drown stuff in alcohol, and the alcohol that I buy doesn't smell like absolute piss. It's actually the stuff that I had at one point was so strong, and it was the worst smell ever. I'm like, I don't want that, so I just do, you know, rubbing alcohol. I could get medical grade if I wanted, but yeah, putting it into a reusable can is awesome. It sprays really nicely. Use different types like it's going out of style. Those fashionistas don't like the rubbing alcohol anymore. I have an idea. I squish. Squish. I squish. Squish the wheel. I squishy. Squish. You get squished. Squish. Hey, that actually is working. Hey, I think I'm onto something here. Squish. Squishing works. Yes. Does squish. This reminds me of FSOL. It's got a very FSOL vibe. What's going on here? I crush my finger. Yes. Yes. That mostly is recovered. Holy shit, that was awesome. I need a little bit more heat on it, I think. Nipex breed. These aren't Nipex. What are these? These are old. They're very old. The Nipex I have are the flush cutters. They're one of the better tools that I've ever bought. Ow, it's too hot to touch. Keep that heat going. I don't know if I want to stream my cell phone repair or not. I'm going to cock it up really bad. I don't want to ruin my cell phone because it's also my insulin pump controller. Showing Nipex on stream? I don't get it, but I'll laugh. Look at that! That's incredible. Okay, so heat would have been the way to recover all of these perfectly. So yeah, heating them up. It's not even like the rubber's not that stressed out at this heat, this level of heat. Oh my god. Maybe it is. What happened to that? What the fuck? Wait a minute. Hey, can you recover, please? What happened? He's dead. I might have vulcanized it. Oh, there we go. That fixed it. Creative application of heat on rubber. Neat. This will be my spare set of rubber wheels. I bought 2 sets of the actual rubber and metal tires for the 128th as a regular set and a backup set, and then I outfitted the extra rubber ones with the rounder wheels, those are much better at a high-speed trial than these are, the ones that I'm recovering, because these are flat and the other ones are rounded. So the rounded ones do really well at high speed. I guess the little nubbins on them are grippier. Even though these should get a larger contact patch, it's just a matter of the difference of physics at scale. Squish. I squish. I squish. Squishy. Squish. That needs heat. Add heat, and then squish. Squish. This is a good album. When did this come out? This was 8 years ago. Holy shit. Why is that number so big? YouTube, what are you doing? Why are you making time pass quickly? Try to break the bead on one, and then I can invert it and then have it peel itself off of the rim. I need just a little bit of force of violence on this in order to get it to remove itself. Look at that. That's coming out clean. And this is a little bit involved, but nice to be able to recover my rubber. And then it'll unmess itself up if I just give it a little tiny heat. Bake your tires. I watched the Clerks animated series, which is pretty good. It's okay. And one of the jokes is about vulcanizing tires. And I'm like, man, you're too old for this. All right, here we go. Vulcanizing tires was a joke in like Hanna-Barbera cartoons, like back in the day. It's like completely dating your media diet. All right, well, this one has a bent rim, so I guess the metal rims are gone. They are trash. Hate to do that, but I guess I gotta. Those are the nice ones, too. I mourn their passing. Let's see what alternatives I have. I only have the ones that I 3D printed, and I don't think I followed through 3D printing as many as I should have. Should've. Shoulda, coulda, woulda. I don't have room for this thing on my bench. This is the dirty bin where I keep all the larger RC car stuff. You don't recognize the term. As I age visibly. All right, let's see here. I gotta get my mic cable over here. I check the music to make sure we still have music because it's kind of quiet for me. Yeah, we still have music. Okay, so the wheels are all over here, and they're just whatever I printed. I need to get the wheels that are specific for the WL Toys kit, though, because WL Toys has this little oblong hub and not a bearing. See, this one's designed to have a bearing in it. It's got the big hole, which is unfortunate because it's a nice fancy looking rim. Same with this one. Whoop. Yeah, these all have it. All the 3D printed rims, I guess, have the wrong kind of thing on the end. I need to print out the WL Toys version of it. These are for drifting. These are my fancy ones. I could load up gray filament and print all the wheels while we're here. This is like a tiny version of the big rubber tire. Weird. Very weird. This is for the other kind of hub. Hubbub. These are the WL Toys wheels. And man, you know, I guess they're for drifting because they're so tiny. They're so tiny. Considered making a peel-off joke, but couldn't put it together. I like peel-off. It's delicious. All right, so I don't have the wheels. I guess we can see whether or not I can start printing a set of 5 spokes, or I could do the BBS style. I don't know which one I'd like to do. I think the BBS style might be a little bit more strong, but they'll definitely break the second I run into something. Let's see, power on the 3D printer then. Heard you say the other day that 3D printed parts are banned in some RC comp events. I don't know why. Maybe the weight of the wheels, maybe they're too fragile, maybe, I don't know. Yeah, it's weird. It must have given somebody a competitive advantage. Like, that stands to reason, I guess, but I don't know what the competitive advantage would be. I made a bunch of fancy wheels and I printed them, and they're pretty good. I mean, they're just that, like, plastic wheels, like, they're just the same, so I don't know why. Let's look that up. Let me back that claim, because, you know, I don't know. Somebody told me in stream, which is the most reliable. I think it might have been Short Lurker, though, and I can generally trust. Oh my God, what the fuck is it? It's a giant thing of dog hair. All right, hold on. I can generally trust what Short Lurker says, but 3D printed wheels. Illegal RC car. 3D printed wheels for the general shorts. Be careful with your 3D printed parts. Be careful with your 3D printed parts, specifically wheels. Much to my dismay, I was messing with the K5 blades and making truck, blah, 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 blah. One of my 3D printed wheels now warped to hell. These wheels were made by Josh 4x4 Toys. None of this was his fault. Well, I blame him. He no longer makes wheels, so I have to fix them. You can just get the 3D model. I'd assume that they got warped while sitting in my hot truck. Oh yeah, that would probably do it. Why would they be banned for some events, though? More warnings on shapeways with printed parts. I have some printed front fender lines on my K10 Ascender. Make sure to never let that truck sit in the hot sun. I have a 3D printer. I'm a huge advocate of technology, but I've publicly stated 3D printed parts are still not viable for some items on RCs. Doubt. You're wrong. You're definitely wrong. You need to get a heated chamber and print some super strong filament. You'll be fine. Get away with more on a crawler. Use light material. PLA, blah, blah, blah. Yeah, PLA is probably unacceptable. Never intended running those wheels, and he told me, and blah, 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 blah. I'd rather have the wheel break than the hub break. Or bend, like it did for me. I'd rather have the wheel explode. All right, let's do a little bit of Octoprint. Octopi, let's get that going. I need to restart the Raspberry Pi. That'll take a minute. And then we go back to this. 3D printed RC wheel band. Banned in the USA. Cool tips and tricks. Is it still copyright infringement if you sell a 3D print file? What the hell are people up to these days? 3D printed tire inserts. That could be a good idea. RC car wheels getting crazy. That looks cool. You do flapper wheels. I don't know. Open RC Truggy. I don't know. Competition rules. Bodies may be constructed of any material, Lexan, 3D printed, etc. I guess it just depends on the event. I don't know why they would be. That's cool. Wait, do they have reasons? All over there's been developing 3D printed cars. Along this, do they comply with tournament rules? If you want to enter my tournament, outdoor tracks, blah, blah, blah. You have to add a lot of weight to get them competitive. Huh. Diecast cars over the decades have evolved from one piece to lead bodies. I don't know. I don't know. You know, I'm used to it being like you want to lighten everything up, but I guess like indoor track foam tires printing, I don't see why that would be so bad. What's up, Camara Sweet? All right, we test, we go to the clipper, we connect, we get our serial number, firmware version rather, BL touch down, I hear a click, BL touch up, we're ready to print. Now I go to temperature and I hit 260 on the tool. Well, 230, let's go to 230. and we wait for it to get up to temperature, but because it's a Revo hot end, it gets there very quickly. I lost the rubber piece that goes around the hot end, the little condom that it has. Minimum weight requirements, and if you lighten the cars, it raises center of mass, allowing for easier flipping corner. Well, I mean, the thing flips like on corners no matter what. I had metal wheels on it, and if you go over a corner too quick, it's just going to tumble. So that's just like everything. I don't know. But yeah, it's counterintuitive. You want to add weight to the wheels so that they, I guess, so that they grip better or something. Tool stuff for work. Ugh. Vex Forums claims it's able to give an advantage to richer schools that can afford custom filaments. I guess that's a totally different animal then, yeah. Yeah, I don't know. I don't know what the reason is. I'll have to find out who told me that. Gave me the misinformation. Let's get the heat gun out of here. Still warm though. Gotta be careful. This thing will burn the crap out of you, and it won't care. Damn it! This radio is so awkwardly shaped. It's not stable in any position. I guess it is more stable like that. It's such an awkward shape. And then they got rid of the C version. They put a lithium-ion battery in it instead of batteries, so the weight is all up here. All right. We got some 3D modeling to do. I have no idea how motion stuff works. I don't know how that works. I've tried it before, making parts that like move in a predictable manner. I have all the data here that would enable me to use this system of attachments and movements to make the model come to life. That would be pretty cool to learn. I don't think I'm going to learn that today, though. Oh, yeah, the 3D printer is up to, oh God, it's been up to temperature for like a year. Okay, hold on. Let's get the gray filament in here so I can print wheels. Wheels should be gray. Wow. Whoa, careful. Okay, let's get that over on the wall. Or at least near enough as makes no difference to the wall. And we'll get this over here. So much stuff all over the place. All right, what is this doing in here? The little rail dust cover inside of the filament. All right, get that. Hopefully that'll line up. I squish, and I squish it until it runs out gray. Oh yeah, it did line up. That was perfect. All right, we'll start in just a second here. We have a lot to do, and I was a little late because I was waiting for people. Waiting for people who don't care. All right, that's pretty light. Need like a dark gray. That'd be a neat filament to have. See if I can clean off the tip here. Gotta grab this thing. Is that gonna work? Maybe. Get all the burnt filament away from my nozzle. Nasty. Nasty business, this. 3D printing is. Nasty, nasty. There's just like carbon from the filament that's contacted the nozzle, and then this nozzle had all this silicon rubber fancy stuff on it that just went away. It just it's inside of a print somewhere of mine, and it's just not worth it. All the fancy garbage. Oh, we put a silicon thing here so that you can grip it. I'm like, well, that fell off. This is the first time I'm able to give this nozzle a bath. Okay, there we go. Let's get all this stuff out of here. Ready to print. Ready to print some wheels. Let's find my wheels and make sure that they've got the proper base, the proper connection on them. Come back over here. BRB meeting. Fun times. We'll be here when you get back. All right, let's see here. So now that that's done, we can get rid of start soon. Oh, wait. That doesn't turn it off. We need to go to setup. Uh-oh, it turned it back on. Okay, now it's off. Jeez. Okay. All right, turn this off too. Otherwise, it's going to dribble. And then we go to Fusion, which has been open since yesterday. And I'm going back to my RC car project folder. Where is that? There it is. And then I've got a whole directory for wheels. A whole directory for, I guess it's wheels and bodies. So what do I want to print? I mean, I've got 14mm width wheels I could do for a high speed thing, but I don't think I have rubber that will fit on this. I made these nice little, these are for the pan car style RC car, because they have this kind of like bearing link up with the pin in it. So BBS Slim, BBS template, and then the Volvo R wheels, but this one is Volvo R for the WL Toys. So let's do those. So for the WL Toys, you have just this little thingy to screw in, and I think I measured this to be exactly the, what is it? Exactly the outer diameter of the screw that I want to use to screw it in. And I made them as thick as possible because this thing will crash at 1,000,000 miles an hour. So let's print that. And I print it without support, which means that these undersides are a little bit sloppy. They're a little bit sloppy, but let's give it a try. So this would be Volvo RWL hub. Gotta be specific. Save as a mesh. Click OK. Click Save. Go to Super Slicer. Why did that pop up? That's weird. Close this. Super Slicer's right in the middle of the screen there. I've memorized the location. I've got too much mess on this desktop. Super Slicer. I'm using an old version of everything. Everything's old, but it works. People come in here and they go, "Why aren't you using the latest version that I just installed?" It's like, I'm lazy. Where are we? Desktop, temp prints. Where is that? T for temp prints. There it is. And then move this thing over. Volvo hub. Bada bing. There we go. Move that to the center. Set number of instances. 4. I should probably print 8, but I think that's kind of pushing it a little bit. Because it's well, I need extras. Let's do 8. And print them just like this. Thank you, Super Slicer. Very cool. Very useful. Thank you for putting them inside of one another. So spread them out so that they get a little bit of cooling time in between, and that'll tend to make things a little bit easier. Just put them in like a random pattern. All right, that's pretty good. So slice and dice. And it can't do supports because I said on build plate only. So in about an hour, give or take. Oh, it is doing supports. Oh, it's doing supports for the inner rim. How did I design that? I guess it goes over the hub just a little bit. Let's take a look at that. I guess I'll have to do it over supports. But in one version of it, I didn't have it do that. I had them go all the way up to the end. That way it was supported. What about the BBSs? These are a little bit more slim though. Yeah, see, that one goes all the way to the end, and that's why these print pretty well. So yeah, let's go back to the other one. And I guess I could just extrude this face to object, and that would be the end of the rim. Why is there nothing there? Wait a minute. Oh no, start was object. Extrude this to object. Here. Done. Okay. And actually that needs to go, but that'll push the wheel. I guess even these wheels have a bit of an overhang, so maybe we just have to deal with it the way it is. Instead of the wheel sticking straight out, the hub actually goes into it a little bit. These will be a slightly wider stance for the car too. Slightly wider stance. Wish I could push-pull this whole thing in and out of the rim to do different offsets. Let's just see if it prints okay, and then we can worry about whether or not I want to like modify it. Because this one I would like to have on a WL hub. I spent there's a lot of trouble getting a BBS rim pattern on this thing. This is difficult to do. But it'd be nice if I can WL-ize this thing. Okay, let's just go ahead with the support stuff. Problem is, if something happens to the print and it sometimes messes up the support, and then that last layer, the one that's inside, is going to be a little bit weird. And if I'm doing that, why don't I have more of an offset? Why don't I make it a proper offset? Let me see what the offset of these wheels are. I just threw them away. Let me go get one out of the garbage. The bent rims that I have. Oh, they're at like the bottom of the garbage. I don't really want to. Oh, there's one. It's okay. It just landed in a bunch of food. Updating software manually is annoying. That's why my copy of Audacity is 4 years outdated. Yeah, that's me using Eagle 7 for a long time. Oh, I guess they're not that far offset, are they? It's like 2 millimeters? Are you kidding me? It looks like it's a lot more. Look at that, like, how is that even, It looks like a huge offset, but I guess that's only 2 millimeters. Everything looks smaller when it's further away, I guess. All right, so let's just print what we got and see how they turn out. So I'm gonna go ahead and send that to the printer, which is raring to go. Did you try to get a fart and it didn't go through? Because I didn't hear anything. The volume is always the same. There's no volume control on the fart machine. It has absolutely no decorum. I'll test it in just a minute here. It's possible that I need to update the whatever it is, what is that? The thingy that allows it to work on the internet. Whatever the HTTPS thing is. I'm going to unplug it and plug it back in. Let me do that. Unplug. Wait a minute, and then plug it back. And if it goes burp, burp, that means it's connected. Yeah, and now it's connected. I'm going to test it. I'm going to test it. I'm going to test it. Yeah, I wanted to just state something that was so stupid and blatant. Huh. Why do you not fart? Try another one. Those are free for me, so yeah, it's not giving me any indicator that that's working. Well, the fart box is not working right now. I don't have time to work on it. I think what I need to do is go in and reissue the certificate. I think we probably did it 6 months ago. Is it 6 months or a year? I forget what the timing on that is. I should write it down so that it's not a surprise. It's like a little maintenance thing that I need to do. Part of this, like if I do actually follow through with my ambitions of making the big outfit like this, making the fart box work via Node-RED and the board work via Node-RED, that would help me reissue those certificates in one location and have more. I could, we got to figure out like the Furby and stuff. We need more interaction in here. I used to stress the interactive stuff, and that's what got us the fart box in the first place. So yeah, we'll have to go back to that. That is for the other style, I think. No, that's the one that I had open. The WL version. This one probably has the Scorpion kit version of it. Yep. Okay, well, anyway, enough with wheels. Let's go back to our... what is front wheel? Ah, this is just in that style. Okay. Cute. Okay, what are we in perspective of the orthofaces? Okay, good. Everything, if you look at like the orthographical view in Fusion for long enough, you can get used to it, and then it starts messing with you. Like things look slightly different when they're in regular perspective. You're like, wait, should that look like that? Or should it look like this. Your brain kind of stops functioning properly, and you get really used to things looking a particular way, which is like backwards perspective. But perspective with ortho is what I'd like this thing to lock to. All right, let's get rid of this. So, all right, we have a little bit of circuit work to do still. These components are not quite in the right spot. We're working on the RC car, and the whole thing about the RC car project is that I'm trying to make this thing like not explode completely. I don't want to have to go out with a soldering iron and fix this thing. I would like it to all be contained and in plastic, and then I can do the high-speed runs, and the wheels will explode when I crash, but it won't catch a wire on something and then stop functioning. And I also don't like the bird's nest of wire that this thing has become. So what I'm going to try to do is, in the only space that we have, which is right above the servo, in the only space we have, I'm going to try to pack all of the electronics. So above the servo is where we have room in this kit. We also have above the drive shaft, which we'll have to get into a precise location, because I can spill out over into this area in order to build the electronics up. We can have the motor controller, for instance, can go all the way over here if it has to. The radio doesn't have any buttons on it though, and the gyroscope does have a setting. You can do the unstable, off, or stable, even though the controller does a lot of that. The controller does a range of aggressiveness. Perspective off in CAD always? No, I disagree. I enjoy looking at things in perspective because that's how they look IRL. But I guess from an engineering standpoint, doing all ortho stuff, but then having it orthographic when you're looking at it from a perspective angle is cancer. So it's awful. So if I could do the motor controller like over here, and we'll be able to rearrange these things better once we get it all into CAD. But if I can get the motor controller to be above the servo, and then I can have it like press fit into a plastic shell, and then I can have the radio and the gyro up top and still see the LEDs on this thing, I would be very excited about that. We'll see what we can come up with, because there's not a lot of room. I mean, I want to keep it below the cross beam, the beam that goes from the front suspension to the rear. I want to keep it below that, or at the same level. I guess what that means is that when it crashes, it'll shear off the shocks, but still, I want to keep it down low and make it like a pan. So we need to piece together the whole car, all the different parts, but we also need to get the electronics sorted out so that we know sort of the sizes that we're dealing with and the heights that we're dealing with. Most of this is just pretty much representative, and we're not going to specifically design for the height of certain parts, but I do want to be able to know where the LEDs are located and design around that. So let's take a couple measurements, and then we can get this stuff into position. And I guess all of my measurements will be taken from the lower left-hand corner. This little cross beam right here, that was put in by, I guess any part that goes onto the schematic needs to have a physical representation in the two-dimensional drawing, and like a grab point for it. And so the grab point for this frame, the decorative frame that I put around it, is that little grab point. Oops. This is the old design, and I want to do something similar, but I want to actually support all the stuff. I actually put mounting holes on my motor controller. It's a damn shame that DOS Micro does not do this, but this drawing is completely cursed. It's had its day. It's too complicated, and all of the extrusions that I've done in order to make the plastic parts here and here have just kind of polluted the drawing. So we're redoing this. This is in the way. Hold on. I need to be able to read all of Chester Willard's comment. Only because, say you constrain two surfaces to be in line with each other, perspective will make it look like they aren't lined up. Huh. But I mean, like, orthographic is specifically for, because like, orthographic is this, but it only makes sense if you go like this, and then everything is flat. And it looks right because it's expanding as it goes further away, but that lines everything up within perspective lines. So you can, this is like a two-dimensional drawing, and so like, for instance, looking through the pinions, I can see that they're definitely lined up with one another. But then if I go to ortho, or if I go to perspective from this view, well, everything's crazy. If I go to perspective from this view, it may tend to look like they're not perfectly lined up. I have to get it to the middle of the perspective in order for it to look like they're lined up. But ortho puts it on a flat sort of drawing kind of space. But it doesn't work in perspective, because that's not how you're supposed to look at it. It's only for these direct views, which is why there's ortho with, why this exists. Perspective with ortho faces. So now we can look at it like this, and if I do this, bop, it bops into perspective mode. But then if I go back and I look at it straight on from the front, bop, we can see that the wheels are aligned. And then it pops out. So, I don't know, that's just how I do it. I enjoy that view. Okay, we're not doing anything with this one. The one that we're working on right now is the DOS Micro, and then we'll open up the exploded version where I pull all the parts in. So we need to get this done. I'm going to close this, even though I probably will want to open it up again just to show people the project. But the schematic we're not worried about. It's the position of all the stuff that we need to just measure and get into place. And I'm going to run into the design rules, apparently, because it won't let me... All right, first of all, I don't need to see the labels for anything. So we can go into our layers, and we can just unview. Layer names are updated for all new files. Legacy files will retain the former naming convention. Click here for more info. Huh, I guess they did a different... they're naming stuff differently. Document top, document bottom. Board outline, silkscreen top, silkscreen bottom. Origins, names, values, solder mask. Weird. Names top, names bottom. Let's do values top and bottom we don't need. There we go. Now we're a little bit more free to work on it. You missed my reaction. Oh no, I just pulled up, I'm probably sounding like a smart aleck, and I just closed the model. All I did was pull up the model and look at it from ortho, from the direct faces, and then showed it popping out into 3D, and probably a little pretentiously, if I'm honest, and I'm not. Yes, I know they're out of sync. Thank you. Jeez, I just moved one part and everything freaks out. Okay, so let's get some measurements on this thing. Pull the microscope in. We're just finishing up from yesterday, and the finishing up is getting it on the calipers. Yeah, I understand what. Just looking at it in perspective, in an from a perspective in an orthographic view. I don't even know if I'm saying that properly. Is weird. It's just weird. I don't think that's too controversial of a view. Actually, wait, this is part of the car. I need to put that over there. Part of the car. Okay, so what do we got here? Got our little board. We measured most stuff. We're basically taking this from the lower left-hand corner and figuring out what the XY is. So we're doing the center of the part. Well, actually, dumbly, the switch that we made is anchored to this leg, the center of that pad. So I need to figure out what the coordinates of that pad are instead of the center of the part. Maybe one day I'll fix that. That's a difficult thing to figure out. It's right up against the edge. So I guess the first thing I need to do is go into the design rules. Where do I get to the design rules? Rules, DRC, ERC. Design rule check. Classes, rules. Huh. Class, DRC, and errors. We're going to open up the DRC check. I think that just did the check. No, wait a minute. Everything's frozen. I just clicked the freeze program button. What's happening here? Is my cat... Oh, it opened a window on the third monitor. Hold on. All the way over there. Okay, there we go. All right, Fusion 360 electronics design rules. I guess I can load. Those are the defaults, but I can also design rules, examples. I think this is from, oh no, that's an example one. Browse. Electron library eagle example. Jeez. CAD and bricking your computer with a single click. Name a better combo. Yeah. You're like, I just want to do one thing, and it's like, the clearances, distances, sizes, annular ring, shapes, supply, masks, etc. These are just everything that whatever board house you're going to use is going to limit you on. So if you set particular design rules, the program, and actually it's getting better and better at doing this, will keep you from violating those rules. So, oh, these traces are too close together. You cannot do this. And so you have to kind of massage your design in order to fit those rules, and that way it prints perfectly for the equipment that they're using. Whoever did DOS Micro did some things that I don't typically see in circuit board production. Usually you avoid getting traces too close to the edge. But in this case, everything is right up against the edge. It's crazy. They have these solder pads that are right up against the edge. It's crazy, crazy go nuts. This is, of course, a part that overlaps the edge, although I've removed the part, but you can see that these pads are incredibly close to the point where I don't really know how I'm going to get a good measurement of this. This is beyond my measurement capabilities. We can get like an about, it's like 0.5 millimeter from the edge. All right. Now, I typically use Seed Studio, which is spelled with 4 E's. 3 E's. So I have the Seed Studio design rules somewhere around here. I think when you generate the board, you can specify that it should go to Seed Studio in here. I think there's actually like, it's in here somewhere. Yeah, I don't want to run the job right now. This is viewing it as produced. This is where you would change the color, actually, of the board, so it looks proper in the other one. That's area and stuff. Okay. Close that. We don't need that. I need to find the rule set for the DRC. Where was that? There was somewhere that it had like a pull down and it had Siege Studio in the pull down. It wasn't the document. It had to be the DRC. Unless there's like a view, edit layers, board shape, blah 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 blah. Short circuits. Polygon, quick route, no, none of that's it. I remember this, but I don't know if they changed stuff. I don't think they changed stuff, though. They don't seem to be very good at changing things in Fusion Eagle. An analysis, I don't need that. Let's see. I'll find it. I'll find it. I thought it would be in the DRC, but I guess not. But I can go into load, and then I can find the DRC or DRU or whatever that I downloaded from Seed. It might be in my downloads. I might have put it somewhere else, though. Seed DRU. What was it? It was DRU. I hope public. I think so. Oh, EDRU or DRU. Oh my God. I don't know where it would be in here. Huh. Oh, 2-layer DRU. There we go. I guess that loaded it in. But now we need to do the clearance to the edge. We need to edit. So minimum distance between objects in signal layers. That's not what we're looking for. Annular ring sounds like a health problem. thermal separation, find a percentage of solder mask overlap, layer stack, top, dielectric bottom, that's correct. Clearance, same signal, different signal, wire pad and via. Where's board edge? Minimum width, blah, 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 blah. See, we need to like intentionally violate some design rules here. That's roundness, that's for that, that's for masks. I guess they gap factor for meanders, no. With the polygons, angle, restrict, names layer, wire stubs. I wish I could just turn off the DRU for this because we don't need a design rule. We're not having a board printed. We're not printing a board. We're just we're making a mock-up of a board. We're making a mockery of this board. Wire pad via SMD between objects in signal layers. And I guess, oh, here, copper board outline, 0.254 millimeter. That's actually within, I mean, we got like a half a millimeter on this. So that would be half of that distance. I don't know if this is half a millimeter though. It looks like it's way less. I can see what I'm looking at is, because this is the solder mask on this board is black, which makes it very difficult to do any kind of analysis on the circuit. It's a multi-layer board because you can see that there are vias here. I need a better pointing device than my meaty finger. There we go. So when you're looking at a board and you're reverse engineering it, and I guess this counts as reverse engineering it because we're doing just a size mock-up. There's a couple things that you can learn just by looking at the vias on the board. And one of the things that you can learn is that this is a multi-layer board, because why would you have a via right here that is surrounded by nothing? And I guess DOS Micro is achieving their designs by doing 4-layer PCBs, which these are getting cheaper, the 4-layer PCBs. I haven't really looked at the cost yet, but with a 4-layer PCB, you can have internal traces that do ground and power, and you can have a pretty good heat dissipation as a result. But these blind sort of vias that are just outlined on the top layer, what those are doing is on the inner signal layers, they are carrying a signal trace between two internal layers, but you still need to get to the outside layers. Now, there are blind vias that exist on the underlying layers, and they would have copper over top of them, but they are incredibly annoying if you have to do any circuit work or any analysis work on your circuit in order to get it to, I don't know, function. Then those internal layers, like the vias that you can't see, are just incredibly annoying. What you can do on this is you can actually poke through the solder mask and get like an oscilloscope on that signal trace, and you can see what's communicating there. So it's good for troubleshooting to have them come out to the outer layer, but then you got to bend your brain around the fact that this via exists on all of the layers. It's crazy good nuts. All right, Copper, thank you for dropping in. Have fun. Working, imagine working. Actually, there are a lot of people at work in my chat. They throw me on because I look like actual. Look at me, I'm doing real science. I'm designing a circuit board, boss. No need to give your employee a write-up for watching Twitch at work. Alt tabs from a gaming stream. Yeah. So anyway, the design rules, I need them to be able to let me put these pads right up against the edge. And this doesn't look like a half a millimeter to me. Let's get something that'll let me see at least a full millimeter and just get an idea of what size. Yeah, this is like 1/10 of a millimeter. Half a millimeter, my ass. I'm gonna call that 0.2. Wait, but that's our design rule. Our design rule is at 0.245. So what design rule is limiting me from putting these pads close to the edge? This is a crazy amount of design. The DOS Micro boards, I'm used to having them be like 2-layer. This is, I believe, a 2-layer board. Oh, wait, because we can clearly see with this thing on the bottom. Let's peel that off. Yeah, I believe this is 2-layer. All those, none of the vias are blind. That one looks like it's a test point or something. China is listening to me is an incredible phrase to start off a conversation with. That's amazing. Father, China's listening to me. Oh my God. All right, hold on. I'll click on the link. Speedy is a trusted link person. They knew we were talking about RC car stuff last night. This is your fault. Oh my God, those are incredibly cute. Look at these little lights. They're little, you can have your little lifted truck RC. That's pretty funny. My favorite are the ones that rotate, but they don't actually rotate. They're just a bunch of LEDs. So, okay, the distance to the edge, 0.254, that should enable me to do stuff like put these very, very close over here, but we're running into some other kind of sign rule. Well, unless this is just, no, because look, I can move it all around here, but then it doesn't let me get anywhere near the edge. If I use the Alt key to do the Alt spacing, it still doesn't let me get within like a huge distance to the edge. Look at how far that is. So what am I running into here? Is it not DRC? Is it a different? So copper board outline. Whoa, when did that change to 1.106? Oh, did it load the design rule and then not apply it? Load, browse, Seed Studio, select. There we go. Okay, there we go. Now we can get those pads right up to the right spot. I'm gonna sneeze. One sec. I'm gonna bring you guys to that view. I think it dried out around here. We're about to get rain though. Okay, I hear snapping noises from the 3D printer. One sec. Am I muted? No. Okay, I had to check to see if I was muted or not. This is how you make wheels. I need some of that like lead weight, and then I could put it inside of the tires. The lead weight strip that Mercedes and stuff use. All right, everything's going smoothly there. With PETG, if you get that first layer printed, generally you're going to be okay. At least if you've tuned properly. But the only thing that would really cock you up after that is supports. Those printing over the supports, if something goes wrong and it ends up creating a giant booger that it would drag all over everything. All right, so now we can get stuff close to the edge of the board. Now that we've got actual legitimate design rules, we can get things to within where they should be. Now you can see everything is moving on a grid, which generally helps your design if you set that grid properly. You go to set the grid over here. In this case, we have 1.27 and a multiple of 1, and then when you hold down Alt, it goes to 0.127. Those are weird numbers. Those are relating millimeter to inch. I wouldn't design something with those. I would instead use like 1 and 0.1 or something of that nature. Yeah, the rotating lights, it is just a blinky LED. They face the LED outwards, so it really does just look like a blinking LED. The ones on Burn the Subs, I actually desoldered the LED and flipped them to point straight up. That was actually the first stream the other Lone Star saw me doing. There's a lot of cursing during that stream because those things look like they're totally easy to solder and flip. They're not. They're very small. They're very small indeed. All right, so let's get this button into the right place. I need to figure out where the button is. I think this might be easier with a ruler. Might be. Let's move the knife so I don't friggin' cut myself on stream. Is that a link to the little ones? Yeah, I've got 3 of them. I ruined one of the lenses on one by accident, trying out a method for making it look a little bit better. So what do we think? 1 milli? 1 millimeter to the center of that pad. Unfortunately, the anchor spot is the center of that pad. I'm gonna go with 1 millimeter on that one, and then to the center. Again, I'm getting in my way with my light. Probably should put a ring light on the microscope, but I do 3-point lighting. And unfortunately, I have a shadow, a big shadow from the light on the right. which is the additional light. All right, so that's we're calling that a millimeter to the center of that pad. So then the other direction, to the center of the pad. 1, 2, 3.2. 3.2 maybe? 3.3. 4 is outright. It's not in the center. I'm going to go with 3.2. The precision in circuit boards is just like completely out of control. So this one would be at position 3.2. And I said 1. That's at 0.704. 1 might be a little too far. But that seems to be where that's located. I mean, the pad looks like it's right up against the 0.5 millimeter edge. And that pad, well, maybe it is. Yeah, that seems all right. So we'll go with that. We'll just put that there, and hopefully it won't be too far off model. Now we got to go to the center pin of this plug. When I say something with that G, Willow runs up to me. She like jumps up on my belly and looks me straight in the face. It's like, did you just say what I thought you said? This one. Okay, yeah. We're getting there. All right, so distance to that. That sits at 4 millimeters. 4 point, I'm calling that a 0.1. To the edge of the board, I'm going to say that's a 0.3 actually. Maybe a 0.4? What would you guys say? 4.5, because 4 goes right up to the edge of the solder. It depends on whether the ruler line is what does the ruler line count as? I guess the center of the notch would be, so it doesn't quite go up to the center of the notch. So that doesn't quite go half. Precision. And then that is in the center of the board, isn't it? Maybe not. We also have to deal with the perspective of the camera messing us up. Why do you have cursed to numbers? Why are you always cursed to numbers? 9.5. So 4.2, 9.5. Let's see what that looks like. Yeah. Close. Well, actually. Hold on, let me position this first. Properties. And then we'll do 5.08 becomes 4.2. And then 9.5. That is barely over the edge. It's funny, it seems like it sticks out more than that. So what does that look like in comparison to what we've got going on in the microscope? I gotta move the microscope up, hold on. I can even make that a little bit more transparent. Looks like it's about there. It's a weird way of doing it, but LEDs need to be moved just a little bit. And then finding the center of those MOSFETs is not going to be easy either. But let's just take it one at a time. So that puts that plug in the right spot. So the LEDs, where are they? You got to make sure that you spell the L correctly and not fat finger it. Let's see. Let's get the microscope out of here for now, and let's go to the actual microscope, and then we can figure out where these LEDs are supposed to be. Once you set up the design rules, this building a circuit board is really fun. Actually, it's just a puzzle that you have to solve. So from the center of the LEDs, which is where the anchor point is, approximately, we're at like 11. 11.8. I'm going to put that at 11.8. Yeah, take that as 11.8. I need like a hyper precise ruler, don't I? And that's what calipers are, but still. So we're at 11.8, and then, because I'm always measuring from this corner. Let's bring in a straight edge here, so I can butt this up against there, and I can measure it this way. Oh, look at that, that's cute. Oh, it's a little bit past that, but it's a 11.8, 18.2, and then 19.5. 18.2, 19.5. So IndiCAD, I gotta remember these numbers. 1.8, 11.8, 18 point, man, that's so close. This would be 19.5. Let's get rid of the 1. We don't need the 1 in there. And then 11.8, 18.2. I don't care if this thing fails a design rule check. It's totally fine if it does that, because our design rules are for printing the circuit board. They're not for laying out a circuit board that's been printed via somebody else's process. So, okay, the pads, well, let's do the FETs and then the pads. So the FET, the top layer FET, where are you? I haven't done something this simple in a while. Oh wait, I do have half markings. Damn it, the other side of the ruler. Where'd you come from? You tricked me. So yeah, let's do this. Using my vise as a measurement index. So we know the width of these things, so I guess I could go up to the edge of the component and go from there. It's hard to figure out where the center is. What measurement tools do I have? Let's figure this one out first. We go all the way up to the edge. So actually that is 10 and really 15 point, hold on. I think this thing got crookeded. Go carefully. So 15 and a half to the edge. A little further than that, isn't it? It does look like 15 and a half. 15 and a half to the edge, but then how big is the, where's our center point of this device? I don't think we get that information from here. Do I have a measuring tool? This is the part that pisses me off with Eagle, is I can't measure that, like any of the distances here. I can go to the 3D design, I guess, and use their ruler. But it's like the tools that are available in the 3D design are not available in the 2D design. It's very frustrating. Measure. Now that's from the top of the beveled part. I want below that. I want that. 5.8 over 2. Where's my calculator? Calculator. 5.8 over 2. I knew it was 2.9. I was just testing you guys. All right, so then we measure this one. And selection 2 is 5 millimeters, so that's 2.5. So we have an addition of 2.5 to the height, and then 2.9 to the width. So 15.5, 17, 18.4. So 18 point, we were at 18.2. We were very close. 18.4. It's almost like the grid they were using is very similar to ours. 18/4. Now we can do from the edge. Now there's, I don't know, there's no telling whether or not these things have centered themselves on their own pads. It kind of looks like they might not be, but it's all I got. It's all I got. So let's do a little bit of this right here. I'm gonna give that a good cool 2 millimeters. You need like a light box to be able to see where the edge of the board is. Edge of the board's right there. So it is the shiny part. So actually it's 1 and... I want to go with a half. Or no, wait, that's half of a half. Wait a second. 0.5. So 0.6, I guess. 6 or 7. I'm going to go with 0.6 of a millimeter. So 0.6 of a millimeter plus 2.5. Properties. 0.6. So that would be 4? Wait a minute. Oh, math. 2.5, 0.6, 3.1. Okay, 3.1. Oh, we were almost there. We were so very close. What does that mean for the other side? That's going to be plus the, well, at 3.1 minus the height of this thing. What is that about? Oh, I hate that info pop-up, and I don't know how to disable it. So we have 20. Wait, hold on. Let's get to the... Here, that one will be from 0 to something. 0 to 24 points. No, I think the width... I think the height is 20. So from 0 to 20. So then it would be 20 minus 3.1. 17, close. Wait, 3.1, 19, 18, 17, 16.9. This is very close. Wait, is that 16 point boobs? No, bobos. And I'm gonna assume that the ones below it are gonna be the same numbers. As well as this one being at 3.1. Already kind of is. All right, and then the middle one is tougher to figure out. If it was in the middle, it should be at 10. Because the height is 20. I gotta check on that. Oh, I know I can check on it. I can check on it by being really dumb and going over here and just going, hey, ruler, tell me what the height is here. Yeah, it is 20. Okay. Yeah, so it's 10 in the middle. All right. So it's 10 in the middle. Let's see. Everybody is adjusted properly. Are these? Yeah, those are on each other, I think. Just double check. 10. Okay, I did both of them. Okay, and then the next question is, what is the distance from the edge in the lower layer? So back to the microscope. We're doing work, chat. We're getting it done. We're doing good work here. It's honest work. 1.2. No, close to 1.5. It's not quite there, though. It seems like it's in the middle of that. Hard to tell. The problem is the edge of the board is tough to see. I don't know if there's like a little bit of overhang. No, there isn't. There isn't. I can do it right from the shiny pit, just like on the top layer. So that is 1 point, half of half, 1.2. I'll take 1.2. So 1.2 plus, what was that dimensions number? That one was it 2.5? Because it was 5 millimeters. So, okay, 1.2 plus, or no, it would be the width of the whole thing minus, what was this? Width of the whole thing minus 2.9. So 1.2 plus 2.9. Really? 3 point... I'm just going to do it in the calculator because I'm sick of these numbers floating around in my head. Even though it's simple math, this is where I always mess up. So we need to move 1.2 and 2.9, 4.1 away from the edge. And that edge is located at 24.6. So I'm definitely 24.6 minus 4.1. I should be able to do this stuff in my head. 20 and a half should be the location. So we go back to the 2D and we look at these guys and they are at 20.3. We want them at 20.5. And this is probably off from the real model. I don't know what their grids were when they designed this piece of kit, but you get some pretty cursed numbers if you just do the circuit board visually. And the funny part is, like, you're sending those cursed numbers out to a board house manufacturer, and they'll just make it. They'll just do it. They'll just do it because it's etching. It's not that difficult for them to make. It's kind of crazy. All right, where are the pads for the MOSFETs? Because we need to consider wires coming off of them, potentially. I'll use a caliper for these. I mean, they are right up against the board, which puts us at like 23.3. But these were even numbers. These were like 4 by 3. And then location is, it's offset because of the capacitor there. We could probably put the capacitors in. We'll do that in a minute. So if it is at 2.6, let's see what that looks like. I have this right up against the edge. That's probably where we'll accept it, but let's go to the 2.667. All right, well, we'll do that one, and then what's the offset on that? Well, the other one's a little low. Actually, what is it? Wait a minute. Can we index it on something? Can I base this position off of the pins? No, it looks like it's off from the pins a little bit. It's almost in line with the package, but it's not quite there. It overlaps the silk screen a little bit. Now, we don't have the same silk screen, so we can't base it on the silk screen, but I was thinking, like, if the pads lined up, but it looks like they don't. Wait a minute. That was the number that I measured to the center-ish of the pad, but this pin is below. This thing needs to be down here, like that. Where does that put it? 1.7. What did I miscalculate? I mean, I guess I believe 1.7. That makes sense. Again, the calipers are totally cursed, huh? So where are we moving? Like 6.5? Actually, I can just do edge to edge. I can do leading edge to leading edge. It seems like it's 6.5. Let's just, I'm gonna bring the microscope in on this. Yeah, that looks like 6.5. No. Utterly cursed amount of precision in circuit boards. They'll drive you nuts. Do. Come on, man. Where does this go? Just like that. And then I keep twitching. You think 6.4 or should it be 6.5? What up, Oscar Gallard? Oh my god, this is tough. Oscar Gallard OP. Well, we're trying to make a mock-up circuit board right now. 1.754. All right, calculator, you're eating good today. 1.754 plus 6.5. 8.254. Bring this in over here and do properties. And then we are at 8.254. Jeez, what a, oh, 825. 254. We're doing the XY positions of all of these. That's not quite right, is it? That needs to be a little higher up. What did I mess up? 1.7 something or other. Did I not take into account the length of the thing? 1.754 plus 6.5. I've got the equation right here. 754, 6.5, 8.254. But then going into this, 8.254, and it is way too offset. It looks like it should go, well, between these 2 points. Let's do the alt spacing and see if that works out. Looks like it should go like this. I don't know. I don't think you can do that in this. I don't know if this allows you to do that. Yeah, I don't think this has the ability to import an image. Maybe it does. Where would that be? You can do it in the 3D design. It's just in the two-dimensional design. I don't think they... Wow, that's a... What is that? Did they buy an analysis thing? It's like a totally different logo. Analyze signal. Yeah, I don't think it does. The base CAD does let you do that, but this one does not. All right, let me see here. Let me just do a center-to-center measurement. Yeah, it does look like it is much more. But I was going from leading edge to leading edge, and that should still get us to the right dimensions. And I got exactly 6.5. That's the number that I used. That's the exact number. 6.5. And so it should be from center to center, it should be 6.5. And they're all lined up very similarly at the lower right-hand corner of the MOSFET. I guess our pads are probably smaller on our model, but 6.5 plus 1 point, whatever this one was, 1.754, 6.5. I have the calculator, I have the evidence, I have the receipts right here. Why am I so bad at this? 8.254, but the more natural position, where it looks like it should be, is 9.016. Six and a half, 1.75, 8.25. I don't know. I don't understand. I don't understand what happened here. Properties. Oh wait. Let's just, yeah, this one is on the grid like that, and then it should go somewhere around here. So yeah, we're mocking up this PCB because we are then going to design a perch for it on the RC car. All right, so those are going to be a little bit imprecise. I don't know. I don't know why it's my numbers are so cursed. Because, okay, this one should be plus 6.5, 14.754. And it's at 15. It's like a millimeter off. That seems to be like it's the position, but it's not. It actually is up here. So there's something I'm not doing. But I measured it. I measured it from edge to edge. Those should be the same position as the center. It's just weird. I don't know what's going on there. Okay, so that's all the top layer stuff. All we need now is the location of the power input solder pads. Good on DOS Micro, they have a lot of vias on their solder pads. That means that the vias are basically riveting the solder pad to the board, and that allows them to be very strong. If you do solder pads on a design like this, especially when dealing with RC car people who are not necessarily the kindest to their electronics, you do vias on the pads, because if you don't, then the pad can lift up off of the board. And especially dealing with RC car people, you're dealing with high temperatures sometimes. And so those high temperatures can tend to bake off the bond between the FR4 and the copper layer. So putting that many vias on the pads is very intelligent. It also allows them to transfer all of that current into the large traces that will carry power around the board. But All those solder pads, very, very good. Very good. I approve. Do these have, I think there are vias in there. I think I see one. Yeah. These have a couple vias in them, which is very nice. Very nice indeed. Okay, so these two. All the way up in the upper left-hand corner, all right? Where's that in relation to the button? That's basically right under the button. Okay. That would have been confusing. Let's grab this, just shove it in the corner as best as it will. And then the other one is gonna be, well, I have a via. I could measure it via to via. Viva la viva. I mean, edge to edge would be the way to find the centers, but for some reason that's been failing me lately. I don't understand it. I don't understand it. 3.29 off of the other one. So we go to this one, and that's at 1.54. So where's my calculator? Where did it go? Is it safe? 1.54 plus 3.25. Unless we're using some other number system, that should be 4.79. I'm going to drag this all the way to the edge, properties, and put it at 4.79. That looks about right. Okay, so those are those two pads. Any other notable things on this circuit board that will slip up, that'll cause a slip up? I don't need to access the programming pins because this thing can be done through a series of beeps. It can be programmed. A lot of this stuff, I mean, it would be nice if I could model it onto the board, but I'm not really going to push it. And then there are two big capacitors that we might need to deal with. So let's put a very big capacitor on this thing. So we go back to our schematic, and I'm going to place a component, and I'm going to place it from, what is errors? What? No. There we go. I'm going to place it from my libraries, and this would be a component, although I do have a capacitor library as well. But let's just look to see what I have. So components managed, and then here's a bunch of capacitors. That's a huge one. That's not what we're looking for. The film cap. That one doesn't have a model. I love it when you can't read what they are because Fusion insists on smushing all your windows until they're totally useless. All right, hold on. I'm trying to find the edge. Where the hell? Oh, there it was. 1 pixel. 1 pixel I can grab. Nope, I missed. Carefully. Carefully. Nope. There. No. Oh, got it. So capacitor film. Ah, here we go. So what size are we? I mean, the cap itself is 1.79 by 3.3. 1.79 by 3.3. Actually, if I do it in inch, then the numbers will be evident. 0.12, so 12, and then this one is 0.06, so 1206. You can see how they get their name. So 1206. Here, I'll show you guys. In inch, you got the calipers right there. I'll have to hold the calipers up to the, well, I can show you on the microscope, I guess, but yeah. So this dimension right here, 0.06, oh, nice. Okay, 0.69, 0.06, and then this one, 0.12 adjacent. If I really kind of squeeze it, there's solder there. The solder kind of throws you off. I had it at 0.12. I don't know why this is. Oh, look, it magically fixed itself. So it's 1206. So we can put a couple 1206s on there. Boop, boop. And then what other caps do we have on here? Oh, we got a couple of them over here, but I don't know if I have a coil 3D model. But they're close to the power things, so I'll put 3 of them on. So I'll put 3 more doot, doot, doot. And then I would like to add the caps that go in between these. So what size is that? What size is that? We keep it in English, and we're 0.03 and 0.06. So 0603. That's the easiest thing I've ever done. So let's get some 0603 caps. And I'm going to put 3 of them down. Doot, doot, doot. And are there notable locations for any other? Not really. It would be nice to have a comprehensive model, but I'm not going to push that. And the coil we'll just have to figure out on our own. We'll figure that one out. Okay, I think the only option I have is just by squishing the board from the sides. So this would mostly be just so that we know that we have clearance for components and stuff. So I think I'm done placing stuff. Let's switch back to. I could put down a couple resistors. No. That's too detailed. It's too detailed. We don't need much detail more than that. So now I'm going to use the button to flip us to the two-dimensional, and there's all of my components. So the first ones that I'll do, there's a cluster under the power button. Oh boy, there's one above and below. So take this one, right-click, center-click, put it on the bottom, and now we have 3 of these. Are those all the same size? Yeah, it looks like they are. So we have one that's just right in between the 2 leads here. So they did one, I'll use alternate spacing, there we go. We got one that's like right there, and then the next 2, you click on the thing to move it, right? No, unless I guess if I use the move command. So right click, center click, and then this one is close to the edge, and then the other one, it's real close to those other leads up here. So I'll grab another one. There we go. Yeah, it's like here. It's like even tighter than that. That is just violating all kinds of rules. And those will be in approximate position. We're not going to measure those and sweat that one out. So then there's one that's right next to the button. God, this is a dense area. One right next to the button. How is that one aligned? As close to the edge as it'll go. Look at that. They've almost gone over their 0.5 millimeter lip. Crazy. Wait, but this switch, we have different sized pads for this switch. As long as the switch ends up in approximately the right location. I might want to move it a little closer to the edge. I'll be able to measure it once we look at the 3D model. But yeah, this one needs to be right up against the edge. That's as close as it'll let me get. Okay, and then the next one is just kind of hanging out right there. That's kind of a strange spot. We'll just eyeball it. We'll eyeball it. Where was it? Hold on a minute. I totally lost my pair. I forgot to remember. Okay, so that's, yeah, okay, that's right over there. It's like here-ish. This might be on the wrong layer. I hope it's on the right layer. What does that look like? Does it look right? Yeah, it looks a little bit too far offset. Actually, it's sort of halfway on the button, so somewhere like around here. And it starts well before. It's like right up against the pad here, like that-ish. Where does it go to? It goes to, yeah, it's about at the top of this. So around here is probably good. Okay, and then the 3 little ones I'm going to put here. Not really going to measure them too much. We'll just eyeball it. That doesn't even look like it'll fit. And how? That's very close. All right, let's see. And then they are a little bit to the right of center. No, you let me do it. Let me do it. Give me this. Give me this. How do I tell it to ignore the rules? Stop it. $15.77. $16. Damn it. That was the wrong dimension. 23,346. So 23.5. Wait, what? 304? $23,346. Come on. I hate that little info pop-up. It's really getting on my nerves. 23.5. It bumps it out. Why'd you bump it out? Give me 18. It doesn't let me. Okay, well, what if I sneak this down a little bit? Pop this thing in there, close to the edge as it gets, and get this one as close as it... Okay, why? You freaking making me a mockery out of me. 23.5. 23.5. And then move this one to the same position, 23.5. Yeah, Eagle needs a little bit of help. They need to go back through and solve some of these more annoying things that it does. All right, I think I'm bumping it up against that. So I can take it and I can bump it. Damn it. Yeah, I think it does need to get... I was like, maybe it doesn't matter. Why does it jump away as soon as I... Oh, boy. This looks like some real nerd shit. It kind of is. When you get into the circuit board stuff, it's rough. 23.5 is the position. So properties, 23.6. Why would you do this to me? 5. Working in metric on circuit boards can be pretty cursed. Just because the 0.1 inch standard, 23.5. Okay, that stayed in the right position. Jeez, the Eagle just does whatever it wants, it seems. Okay, so now we've got all of our major components on the board. We can go to the 3D render. The 3D render. And so we do this. Bop. Push. .54. Can't you add up things in 2.54 increments? It's easy and fun to do. I think there's, maybe not this program doesn't do it, but some of these programs can render the solder, which is kind of amazing. I don't mind these being solderless sort of placeholders, it's fine. But this is now our motor controller board, minus a bunch of stuff, but this will allow us to design the 3D printed components around it. And of course, we don't have to worry about the clearance of this because I desoldered it. I do have another one of those connectors if I really want to use it, but yeah. iBuyu's comment is one of the better things that I've ever read coming from chat. Okay, so this is our DOS Micro motor controller. Save. Good. I guess I want to, because this is kind of a really important position, so let's see how we can figure out what the distances are involved in here. It better not crash on the save. There was I've had that happen before where it crashes right after saving. These look like they need to be closer together. No, maybe they're okay. Maybe they're okay. So let's get like the edge of the switch to the edge. Well, I really want the button. If I don't know if the inspect tool is going to help me out here. From here to here. Angle, 90 degrees. Thanks, man. I appreciate that. The cat enjoyer in me likes the attractive model. The FEA in me absolutely hates everything about it. It's the attractive model is really what I love about Fusion, because it that's what my circuit board's going to look like. It's really cool. Of course, having the layers have depth and everything. This is just stuff that the precision of circuit boards. You know, we know this stuff. We know what the etching is going to be like. We know, you know, all those figures. How do I get the actual? This is the most useless measurement ever. Spent at least 4 hours removing features from a nice model today. Oh God. Yeah, my friend did a little bit of FEA, and he's like, I never ever want to do FEA. So if I do that and hit Control, then I can select the center here, and then if I select this plane, it should. Damn it! Why do you do this? I need an XYZ out of this. 3.77, this is like the most useless. How come I can't do an XYZ in this measurement tool? Did they nerf it? Or do I need like a different measurement? No. That's really weird. I don't know why they don't allow me to do a proper measurement of XYZ coordinates, because I need to know the center of the button to the edge of the board. Just nerds enjoying nerd shit. Easy. Clap. I'm kind of SOL on this one here. If I do a point to point, maybe it'll give me an XYZ. So if I do this and I hit Control. Oh, I need to show snap points. I hit Control and it locks me in, so I can select that center point. And then from that center point, I'm going to select, I guess, this corner. And now I have that. 3.05. I need a different one. 3.2, 3.05. That's kind of a difficult. I mean, doing the ruler would be easier. The ruler. Just give me your design files, DOS Micro. So this one would be 3.05. That's very close, but it's not quite right. I guess we don't have to stress that much over it, but I do kind of want that to be well represented. Ah, damn it. 3.05. Oh no, 3.2. 3.5. It's looking like. Looks like it's a little bit over 3.5 because it's not, that line gets real close to the center, what I assume is the center of the button actually. I don't really know what the center of the button is. That's just a mark that looks like the center of the button. I think I'm taking some things into assumption here. Well, it would be 1, 2.5 to the edge of the button. Let's see if we can get the button edge on here. The CAD's not going to like that, though. I think what I can do is go from here to here. Oops. I didn't have a tool open. Here to here. Cool. Very cool. Thank you. On measurement tool, what are you doing? That's just the same point to the same point. What the heck? Okay, so from here to this ring, I don't have any other units available to me. That's annoying. So on a cylinder, there aren't any snap points. Isn't that just annoying? All right, so what's our diameter here? 1.884 99 is 18. Duh. 0.9. So that 3.05 minus 0.9. I don't fucking know. It's in the right spot. I'm not going to stress this anymore. I'm so done with these numbers. We'll take this into the main model. So let me, I already saved, we didn't change anything. So I'm going to close this fully. We're just getting out of here. We're getting fully out of here. And then we're going to open up the exploded view. There it is. It looks like it exploded. And we need to piece together this entire model basically now. And I now have the electronics, and we'll be able to figure out where to put them. Bonk. There it is. One warning. One component is out of date. What did I update? Oh, this thing. It's like exactly the same as it was before. So, update external. The one thing that I would like Fusion to have is I wish I could put all of these components into a folder. I wish I could put them in something to organize them, but it doesn't let you do anything like that. I could use this model once we put it all together as a component in the next one. Oh, I see. The update was the visual thing. Well, we'll go back to that later. We'll go back to that and add wheels later. I think what I'm going to do is I'm going to put everything together and then use that as a component in another, like an assembly in another another document where I'll do the 3D stuff, the bodies. So we have all these things all strewn out all over the desk. Let's put it together. This is where we need VR. Oh, that's finished. Sweet. I got a bunch of wheels sitting behind me. Looks like 4mm. I'm not editing it. I'm done with that editing. Where did you come from? Where did you go? Where did you come from? Cotton Eye Joe. But I've been Cotton Eye Joe. I've been married a long time ago. Where did you come from? Where'd you go? Where'd you come from? Cotton Eye Joe. Okay, yeah, so that component I'm just going to move out. Let's find it. I don't know if I can edit its position from here, because as soon as I move it, now we're going to leave it there. I'm actually going to leave it there until I need it. It won't be too long from now. Let's get started. All right, we're going to be using the move command, and I'm going to move the components. I love it always selects bodies, move component, and we're starting with these guys right here. And we're going to go point to point with everything, because we can go from the index, the pin that indexes. I thought I selected point to point. Do we not have any? Oh, I need to select the component. We're going to move this. Our first point is going to be the top of that indexing pin. And we are moving it to what position? This one is the rear housing. And so that one goes to, well, it depends on the position, if we're doing the narrow or the wide. I guess I'm going to go with the narrow position. So in the narrow position, this is at, where's that pin go? That's a Bringo. That would be the forward. Okay, so the pins don't have, I don't think I did the tapered thing on these. Yeah, I didn't. So it goes to here. And then I'm going to click OK, and it's gonna want me to capture the position. But I'm not going to do that for a little bit. I'll put everything together, capture the position, save the file. And then that'll be our little secret. Okay, so move a component. Where are you? Oh God, I can't use the tree. It's totally useless with this many parts. Where's the move command? Really? This thing expanded and it got rid of my move button. That would have been so nice. I guess I could use the M key. That would be the better way to do it. Okay, so this pin here, and that goes to the front position, which is here. Bonk. There we go. I didn't model the bumpers. I guess I have an STL file of the big wide bumper without the foam, but I don't think I'm gonna bother to model that. We did a fairly comprehensive job modeling everything, but it's still a fairly minimalistic thing. I think maybe the servo we're gonna not put in. Oh no, but I need to know the positions of everything. So I guess I'm gonna float the servo in approximately the right position. It'll just be a floating element in this that you can turn off to ignore. I also love how I was able to find the exact model of the servo. Okay, so what are next? The A-arms are gonna be bent downwards. We did that in the other model, but I don't know when I did that in the other model. Because if you move it, you're gonna have to move a bunch of stuff at once. And I don't know how to do the Fusion 360 thing where you know, move it exactly. You set the component to have like limitations and movements, and you can chain stuff up. It would be really cool to be able to do that if I were good at it, and I don't know what I'm doing with it. So, all right, I guess we put this into position first. That was the axles that I bent. So I guess what I'm going to do is I'm going to start using the M key to do the move command. So we're moving this one, and then we're selecting our point, and it's going to be this, and I'll move it to here. I don't know if I should bend it now or not, because I can rotate that downwards. I guess I'll wait to bend it. We'll just put things into position right now, and it'll be preloaded. It's ridiculous that the amount of space that this thing has to move is just between. It's like barely any suspension movement on this model. I wonder if I should shave down those ends. Yeah, the distance is 0.5 millimeter between them. Does that track? Is that? Yeah, that tracks. 0.5 millimeter. All right, so we'll get all the A-arms in here. M key, this. Put this. This is like building it IRL. Only it's not. I assume that there are games that have you doing this kind of thing. I should just get Rob. I should make this, call this a game, an early access game, and send it to Rob Oz, and he'll do this for me. He'll just do all this stuff for me. Oh, this is a great building game. Totally not doing my work for me. Yeah, it's an early access. It's gonna be a very popular game. It's called Build an RC Car. Which actually would be, that would actually be fairly awesome. That'd be a good RC car game. You'll find a way to break it. I don't need to break Fusion 360. It does that on its own. It's a feature already in Fusion 360. All right, all the A-arms are in. Let's get some of this stuff on. This point to point, this point. And this is fairly cathartic, actually, building a model like this. I don't mean a model car. I mean a model, 3D model. Next one is this one. Oops, that was the N key, not the M key. He would probably do something cursed with it. It's funny, all these early access games are now coming to Discord only. So for that, the car game, you were only able to have early access to it for a certain amount of time, and then you would also have to join a Discord to get into it. And I think Tomato had his moderator join the Discord in order to get early access to the game. But you only had a couple hours to stream it. Not popular enough for that. Now this is components, so hopefully it brings all this stuff with it. Hopefully it doesn't separate out my Switch into 5 different parts. I would like to get the Switch working when we put this together. It blew up my Switch. Why is that Switch multiple different components? How is that even legal? Highlight it, select move. Now it's on bodies and nothing is selected. Why would you do that? Components, this whole thing. There we go. So from, you can select other origin points that aren't on the actual thing you're moving, and it will move it the distance between the two objects. Such a weird thing for it to do. But I guess it would come in handy in a very, very, very specific situation. Okay, there's my whole switch moved. I always hate it when it doesn't move everything with one component. It's like I brought it in as a component and I said move the component, not move the individual piece of the component. But because I clicked on the individual piece, it thought that I was separating my switch out. All right, so let's see here. Yeah, how am I going to do that part? Well, this is, which end is the front? The motor is at the rear. So this is the rear end, this is the front end. That tracks. I think the front end is all the way at the front, right? That's a weird statement to make. All right. Did I make all of this? I modeled all these parts. Some of them are modifications, and some of them are just like the real part that's there. Everything except for the servo is modeled custom by me, including this battery, which I'm pretty proud of. I made just the right representation of the 2-cell battery. Oh, and the shock. The shock I did not model. I don't know how to do springs. So I brought in a model of an RC car shock, and then I scaled it so that it was the size of the actual physical shocks that I bought. But most of it is me reverse engineering everything. Oh wait, that bearing is the one that I want. So this one is not. Where is you? Where are you on the tree? Show me the bearing. There it is. Bearing version 1.1. You are deleted. Bonk. Okay, there. This is so this is deriving from my previous work on this. Many years ago, I put together the model and did this. Housing was the most difficult thing to model in the entire thing, because it's got, why are we locked in on something else's dimensions? Here, see that? No. Why are we doing this? There we go. Fusion View kind of sometimes freaks out a little bit, and you end up not being able to move things the way you want to. But yeah, that housing was the most difficult thing to model, and it's still not exactly right. It's just the external connections are correct. So we're using this right now in order to figure out how to put the electronics into this thing and have it have like a plastic housing around it. This component from here to here. And there's a little bit of wiggle room in there, which is just the way the 3D print comes out. So it'll be a little bit cursed when it goes in. Here, select the point, select this one, and we'll do, actually I'll do the other side of that. I don't think these will come up in our design, but you know, you could save yourself all this time. I'm doing this a specific way because I'm broadcasting it and having fun doing that. But you could save yourself a lot of time and just do like a representative enclosure of where the stuff is supposed to go. I like having a big, beautiful 3D model right in my face, just rubbing all over my face. We'll measure the distance and put it in the center in just a sec. Let me just get these all positioned. Move, and we'll take this one and we'll put it on the front side. I could actually use the tools to do that. So let's see if we can use the tools to center this thing properly. So now I'm going to hit the move command, choose this, and then we're going to measure the distance and take half of it. So then I go to this type of move, and if I click one of these other ones, it will only be able to do it to one component, and it'll deselect the other one. You got to be careful. When you jump around these different types of movements, it'll make assumptions. So we are moving it this distance, so that's Z, and then I'm going to measure from here. I want the whole plane to here. I can select the plane. Please show me the whole plane. Oh my God. 1.73 over 2. Are you kidding me? Control Z. Okay. Let's try that again. Move this on the Z axis, and then I measure from here to here, 0.70003 over 2. Oh, it hated that. Okay. It doesn't do equations in here? All right, so 3.5, 0.3, 0.35, and that should center those two. But it deselected the other one, so I need to go back up here, select this one. It doesn't let me do that? Okay. Why? Why must you do this to me? All right, cancel. Did it move back? Oh my God, this is where your fusion model gets all cursed. Move this one and this one. Oh, it changed my axis, hold on. When you select the axis, if it's flipped, it'll be a -1 or a +1. You gotta make sure you select the same thing. So there, and now we're moving in the Z distance, 3.5. There, now they're centered. Easy peasy, super duper easy. And then these I'm gonna move on this axis, there, and we're gonna go in Z, 3.5. There it goes, cool. Okay, those are centered. After a trade for our sanity, we gain a centered position there. All right, let's do the motor housing. So this, we're gonna move based on the pin, so point to point. Did it? Oh, it didn't select it yet. Okay, so this, we're gonna go from this ring right here, and I'm gonna go to the big one, which is right. The pin is which position is the pin in? Okay, so that's to the right of the. So that goes here. Looking good, and hopefully these don't collide. Oh, they get very, very close. So we modeled this pretty accurately. You can see it. Oh, there's a gap. Ha-ha! So we modeled this pretty well. In the real thing, they get extremely close to one another. Oh, I took it out. Where'd the motor piece go? Where'd it go? Where'd it go? Hello? I saw it. I saw it a minute ago. I know it's here. Losing this part would be very annoying indeed. Although now I have a 3D model of it, so I guess I could print another one if I really need to. But I shouldn't. I should not need to. Wait a minute. Where did it go? Wait a second. I don't know where it is. Get this out of the way. I probably got pushed and pushed and pushed. These are the bad tires, the emergency tires. Put those over here. Huh? How am I missing this part? This is the most important part. It was the most important part. Where did it? There it is. It's all the way over here. Okay. Oh yeah, the drive shaft goes through this, so I'll just remove that. I'll just remove the back suspension. You can see it right here. Yeah, they are extremely close together. There is barely any room. Sorry about the random farts. It's not working right now. I already told you guys there's no guarantee of it working, and I guess these certificates have probably expired. I just need to reissue them. I don't have time. We have too much to go through here. Why am I getting all these random farts? What's going on? What did I miss? I'm not refunding anybody. I need to get the random farts off of the activity feed. I can see too much. How do I do that? Filter. And then reward requests. There we go. Cool. There we go. It's all right. Nothing's happening today. The last thing to happen was Gonad shouting me out on a stream. But yeah, this is actually fairly accurate. It's always fun when you model a bunch of different stuff and get the numbers right. I'm gonna have to, I gotta take matters into my own hands. All right, so let's do the next piece. I guess I can do, where are we going? Where are we going? I mean, there's so much to assemble here. I can do, actually I should do these next. So let's do M. We're doing a lot of move commands today. See, that didn't select the whole thing. So I need to do, I need to press M and select the whole thing like that. That's super annoying. All right, so it's super annoying because it's already one component and it may be made up of two like sub-assembly pieces. If I click on it in the tree, it will move the whole thing. But if I click on it in here in the actual CAD window, it will move only the one thing. So it's just an annoyance. Yeah, release that butt dust from your office chair. M, select, point to point. What I should do is do this in individual steps and lock them down every single time so that I can get an animated graphic of this whole thing going together. That would be pretty sweet. Or I could just take that portion of the window right there and use it to make a sped up GIF later on. But the software lets you hit play through the steps and it'll go through the different steps. So if I made all of these insertions individually locked down steps, you would see all the pieces arranging and going together within the CAD program. That's actually kind of a good idea. Maybe I should do that. After each individual position move, it'll have I'd have to hit Control Z a lot to get back to where we were. But that would allow me to zoom out and hit play, and it would be this RC car like assembling itself. Damn it. I am about to hit Control Z quite a bit, chat. We're going to set ourselves back kind of a little bit in order to do this properly. So here we go. I am a clown. Okay, we got to redo the update. And then I'm going to hit lock after every single move. And that way I will get a cool animation out of this file. So I'm going to run through this as fast as I can without explaining to you guys what I'm doing. That's how we're going to roll. Inward position. First step. And we do, I wonder if I should make it like end by end, and that way you don't have to move the camera around a lot. I guess so. So move this there to there. Let me move the camera. Why is it micro movement? Jeez. And then move the other side in. It's going to make reworking this really, really annoying. But it'll make a better animation, so you get the deal. Make sure that's good. Yeah, that's okay. Okay. So then I do these. Make sure I capture the position. Yeah, no. Here to here. And then move this one from here. It looks like in the original grid, it doesn't like moving around at all. It put some like microscopic movement on me, which was really annoying. Oh, that's the wrong side. So we unselect that, select it again, and I hit this, and I go to here, and then I hit move again, Did I capture that last one? I think I did. Yeah. Another move command. Make sure to hit that first. Oh boy, this is annoying. Move this and this, but we're moving it like that. And I'm selecting Z is negative 0.35. Why would it? Why is it doing that? Where is my pivot point? So annoying. Okay, come back here, please. Point to point. Component is this, and select. Make sure I capture the position from here. Try to wrestle my view to here, and then move. Whoop. That's so annoying. It doesn't know what I'm looking at, so it's going very weird with the view. This one, oh. Here over to, ugh. There. Okay. Yeah, see, this will be able to play through all this stuff and it'll look cool. Move this whole thing, capture the position, origin point, top of that ring, that goes to that ring. All right, starting to look like an RC car. And then we do move, capture position for this one, and the point to point is here. Here. All right. Move, capture position. Did select the right thing, I think. There you go. And we do this one. Come on. From there. This will look really cool when I'm able to hit play on it. Okay. And then, am I doing this all at once? I guess so. Yeah, we're on point to point. I select that. Gotta go over to this. And that goes, actually, it should probably be from the top, shouldn't it? From the top. So let's see, how am I gonna do this? First of all, unselect that, go to this, rotate it, and then go to point, and then do from this ring over to the other side. This is the rear, right? Yeah, this is the rear. Set it up on that. I'll have to rotate the A-arm in a second here. Actually, I can just do it now. Did I capture? Uh-oh. I did. Okay. So then move this guy, capture the position, rotate here. And then that is colliding with the carbon fiber, isn't it? Yeah. Well, I'll just put that there and let it clip. It'll just clip for now, because this would be compressed a little bit. Seems like it would be compressed when it's in position, but okay, there's that. Show, that's okay, do that. So we remember negative 10 degrees, so they all have to move negative 10 degrees. I keep forgetting if I am in love anymore. Let's see, M, grab this thing, twist it, bop it, capture position. No, not capture. Well, yes, capture position, because I'm doing multiple moves here, but I want at the end of this, 180, and then we do a point to point. We go from here to here, and that is that step. Click OK, and then I move always click the capture position because we're making a video, and the twisty on this axis, and it's 10 degrees. Nothing moved. Oh, I didn't select the component. Can I not? It wouldn't let me select. Wait, what's going on here? Okay, I guess cancel. That was weird. It wouldn't let me select the component. Oh, this one didn't capture either. Either. No, yeah, it did. Yeah, okay, yeah, it did. Okay, 1, 2 frames forward, and then I am moving, twisting, capturing this. There it goes. I don't know what happened to that. On this axis, 10 degrees. Okay. It makes it kind of look like it fits. Kind of. You could make the argument that that should fit. One day I'll learn how to do the proper movement dynamics in Fusion. It's very confusing to me. I don't know how to do that right now. I should have 2 extra bars. I need to maybe make those sub-assemblies where this goes to a midpoint here, because that's how the rear is now adjustable with the toe-in. I did a modification one night. I did it the other night, and it's using the body posts in order to keep this honest up and down. But I have all the components to make that. I don't have it right now. So we'll skip that. We'll omit that. So the motor is towards the motor's towards the rear. So oops. So wait, this is the front. Ah, crap. This is actually the front. I messed up. Actually, what I can do is, do I have a center point to rotate them? No. No, I wish I did. So I need to swap these, and I guess it would be funny if they just suddenly fixed themselves. Oh, I got to do that every step. Yeah, if there was a center point, I could have rotated them around it. And that would have put them in the right position for steering. So I move one away and then move the other in the position. I guess I could do the swap in one step here. So I won't capture this position because I'll move one away. Well, I need to move them both away, actually. Capture that, move this thing point to point here. I keep getting mixed up about which end is the front end, so... Oh, damn it, that thing is still there. I Control-Z'd myself back into having that component again. Well, let me finish this before I do anything. So I'm going to capture that and then move this right here, point to point. From here, there's got to be a faster way to do this. To here, capture the position. Okay, I'm going to rewind time now and get rid of that bearing. Delete. There. And go back forward in time. Donk. All right, there's our assembly. I'll put the wheels on last. That's looking good. Okay, what other components do I need back here? I think we're done that at the moment, so we can go. Well, I could do. Nah, I'll do that one later. Well, might as well do it now. Okay, so move this whole assembly, and we are going to flip it over. All right. Oh, you know what I could have done? I could have chosen those 2 parts, and then it would have put the axis in the middle. And I could have rotated them. Oh well. It doesn't show the animation of you like flipping it over. It just does a frame by frame. So move this stuff. Really? You're gonna be like that? There we go. Point to point from the bottom of the screw thing to right here. Oh wait, you know what? I should capture the position in between just to have that part flip over. I'll click move again, and this time capture it. And I will do this stuff, and then I will do a point to point from this point. It's like difficult to, oh, come on. Really? Where is that point? Jeez. Stupid camera. All right. Beautiful. Why is it pivoting from a weird spot? Stop it. Move this thing. Let's see. That is off 180. Let's see. Which direction does it go in? It goes opposite of where the... So it goes to the motor. Okay, so this needs to go 180 degrees. So I'll just do this and then capture it and then do yoink. Oh, come on. Come on. I guess that's not visible in the model, but it's not moving with the model either. But it's like a cursed thing. Why are you like this? Okay, where is this assembly? I need to select it here and then right click and use that to move copy. I'm not doing a point to point, we're doing that. I'm capturing the position and then I'm going 180 degrees. It's not moving the other component with it. Why does it do that? I don't understand. I guess if I view the component and I can open up the tree here. There are the two ball links, and then here's the second no ball link, but I can view the other ball. And now if I go to move and copy this whole thing, the ESC dev boards, those were cool. It looked like you could do a lot of really cool stuff. One selected. I am going to toss this program out of the window. Okay, there, like this, and then go 180 degrees like that. See, now it all moves together. It's so stupid. All right, did I capture that? I'll capture that, and then we'll move this point to point. So it's going to be from here to here. Capture the position. Okay. All right, there's our steering linkage. Good, good, good. The Dev ESC is neat. They come with a legit ST link. Oh, that's nice. Tends to overheat. What, the ESC or the ST link? Which one's overheating? What else do we have in the front end? I think that's everything but the servo. And the servo doesn't exactly meet up with the rest of this model. Now, I could base the servo off of the previous one's position and put that in there. I kind of think I shouldn't put the servo in at all until I have the lower part of the servo mount. But if we're keeping the lower part of the servo mount the same, I guess I can pull the model that we made a component out of into this. I don't know if we'll want to modify that at all. So I guess maybe I'll rewind time all the way back to here, and I'm going to take the component and it'll become part of this thing. So this would be in the WL Toys parts, and then we exported this from the other model. I feel like I smell soup all of a sudden. Am I having a stroke? Is smelling soup part of having a stroke? Oh, that's naturally in the right spot because it was exported from the previous model. I'm going to put it over here. I'm going to intentionally mess it up because I'm trying to be fancy and capturing every single step of assembly in order to make a cool little timeline that I can hit play on. So move this thing, capture the position, go from point to point. We're going from the front right all the way over to this hole. Bop, bop. Good. All right, so next I got to figure out how I'm going to place the servo in here. I guess I can go from a particular point to a particular point, and it would only be off by a little bit. I don't know where else I would be able to capture from, because it's not like I don't have like an assembly center point on this thing. And those are tapered. So if I move this one, oh, it has to be both of them. I hate how it does that. And then we're going from the back corner, which isn't intensely accurate. I don't know. Back corner to this. It's two corners. Put it in the middle. And we got to move it like 0.1 or 2, probably 0.1 left and forward. So I'm going to go to this type of move, and I'll select that, and we move it this way. Negative 0.1. Does that look about good? Maybe 0.2. Everything has been given a 0.2 clearance, so we need to move it off of that clearance. Forward 0.2. Capture the position. Okay. All right. There we go. We have installed the servo, and look at how nicely it functions. That bar I actually have shaved down on the real thing. I shaved that bar down in order to make the center position of the servo the center position of steering. It'll just be a little bit cursed in this. That's funny that it's actually even with the steering bar. I wonder if I probably altered stuff a little bit, because the servo saver sticks out quite a bit from this. But if we leave it like this and we clearance the motor controller based on this thing's position, it should clear everything else. I'll get rid of that ball. Bonk. Okay, cool. So that's the front assembled. It is a very annoying thing to do it like this, but it will build itself if I hit the play button. So let's move back to where to all this stuff. So more moves, more captures, more objects, more points than you could ever stomach. From there to here. Okay, move this one from here to here. Bada bing. All right, those are the two battery holders. I guess we could do the motor piece now if we're working our way backwards. So move this thing with the capture from, oh, did I not capture the previous step? Dun dun dun. Capture it. Move that. Capture. Point. Point. Yeah. To point. There we go. There's our motor holder. I guess we could put the motor in. What direction are the little motory thingies facing? I don't know, because I took it out. Shit. I don't know what direction these things are facing. Hold on a second. Just hang on. Think about trying to do this in the animation section of Fusion 360 before doing capture components? No. No, I didn't. A motor home? A home for the motor. No, because I don't know how the animation stuff works, and I am simply, I want to be able to just hit play on the model and have it do the stuff I want it to do. I don't know anything about the animation. I don't know if it can do this or if it'll try to do something similar. I've never used it before. Yeah, so it's at an angle. It's at like a 45-degree-ish angle. A little bit more than that. I don't know how to represent that angle. Back that angle up. I think it's 45, but I mean, well, I'll put it in and then I'll spin it into the right position. Maybe we'll do it that way. Because, yeah, what I can... Is this pimp my RC car? Somewhat. So I'm going to move the motor now. You can do this in the animation section. It has exploded thing too. The way you constrain assemblies, you may have issues trying to animate motion study a model. I haven't gone into the animation stuff. I don't know how to use it. It would be fairly interesting to figure out. Oh, whoever made this model didn't end that there. Let's just take the front face then. The front fell off. Okay, go from here to... where is this? This doesn't have a center. What the fuck? Okay, well, I'll take it to this center then. Really? Oh, I didn't select the component. And now it won't let me move this whole nonsense. Yes. Point, capture, front ring to the rightmost position, even though I think it's probably going to mostly be centered. I've installed the motor. And look, the holes line up, but ours is actually going to be at an angle. That's fun that the holes line up. So I'm actually going to view down the barrel on this one, and then I'm going to move this thing. Does it all select? Good. Rotate and rate it on this axis, actually on this axis. There you go. And we're going to go until it looks right. Oh, look at that. I didn't select the whole thing, so the back isn't rotating. You son of a bitch. I hate these things. Cancel. Now how do I select everything in this model? What an absolute bastard. I have to go from the tree. So the motor is where? There it is. Right-clicking from the tree gets everything inside of the that thing. Where did my view axis go? Where is it gone? Watch as oh bother gets madder and madder at Fusion 360. Oh, there we go. That's pretty much where it is. And then the two holes. It's almost exactly 45. Okay. Near enough as makes no difference. Cool. Okay, so there's the motor. Oh yeah, I want to capture that one. Always capture the positions. Oh, let's get the switch and the battery in. We're just going from end to end on this. So I need to make sure I select the whole thing. Yes. Capture. Select. Oh, I'm not doing, no, point to point. 184 selected components. What? In just the switch? In this model, there's 184. I don't even think there's that many parts in a switch. Let's count. Let's see if we can get to 184, right? So there's the outer metal. That's one. There's the plastic lever body, the main, you know, the grippy part of the switch. So that's two. It's 184 we're trying to get to here. There's the FR4 base plate. That's three. There's the three contacts. That's six. There's a piece of copper that goes onto the plastic. That's seven. 184? Something must be broken out into individual, like, faces. Absolute madness. Reset the home viewpoint. Oh, okay, yeah. There, go to that, click OK, and I can do home. There we go. Hopefully that, yeah, that helps a little bit. I guess Fusion gets kind of sick of your shit after a little while. Okay, how do I locate the battery? That's a tough one. I don't really have anything like constraining it. I can just move it like in free space, I suppose. Oh, did that one captured? Okay, so I'm gonna move this face of the thing. Okay, I'm gonna move this component, and we're gonna go point to point. We're gonna go from this face just to wherever, right? And then now I'm gonna use these and just jiggle it into position. Point 0.5, 0.4, 0.3. 0.4. Did I not capture it? Hold on, wait. I think I checked before I started. Hold on a minute. I'll do this and then I'll check. So 13.45, 44, that's good enough. Just as long as we're not clipping into anything. And capture that. Let's see what happens when I roll it back one. No, I got everything. Switch, battery. There we go. Okay, that leaves that front housing, I think. It's looking good. This is looking cool. I like this. Oh, motor. Yeah, motor's front housing. So let's do it in order. Well, actually, getting that housing out of the way would be nice, but let's do it the way that I would do it. So I'm going to take this and I'm going to move it to the very point to point. Jeez. Select that component. Move it from here. The view is starting to really fight me. This is, I think, well, those have centers, so maybe that'll be, yeah, that's on target, okay. And then move pinion. That's probably not going to look good, but whatever. I don't think there needs to be that gap there. Yeah, that's rubbing. .5. There we go. Okay. And then I guess we can do this one based on where the drive shaft is supposed to go. I guess maybe I better move the drive shaft. So the drive shaft is going from point to point. Really? Oh, it didn't select the thing. Yeah, okay. So the origin point of the center of the shaft, there. And then we go to center of this, which is split in half. And then I move it forward just a little bit. Although it doesn't really need to be moved forward, but we just poke it in. There we go. Good. And that captured. So now we have the bearing to do. Where's the bearing? Where did that go? There it is. Move the bearing point to point. This is going to be basically what we're doing, is move thing point to point, etc., and capture position, you know, just over and over again until we've made an RC car. We're almost there. Well, we got a little bit of work to do. That needs to go in there. That was the easiest bearing install that I've ever had. Why is that off? It was the wrong center. All right, let's go back then. Double click on the step and it'll show you what moved in that step. Wait, why did both of those move in the step? Hold on a sec. Finish position. Oh yeah, I didn't hit capture there. Well, those two can move at the same time. I'll make an exception. I did forget to capture. So we go back and edit this one. And now that one needs to center on this stuff, but it didn't. Or maybe this one's off by a bit. I mean, we pretty carefully measured this thing. So why would that be like that? I know it's not tilted. I don't want to do an analysis view. That would be annoying. That is definitely centered. So our measurements are off. Well, that's as good a time as any to hit save, finish position, bring this out to here, and let's figure this out. Let's figure this out. Now, is this off? That looks like it's good. It's just our bearing hole is in the wrong. Plus, that bearing isn't quite the size of the hole, actually. Did this go into the thing wrong? Hold on a second. So I'm going to undo the step where the bearing goes into place. No, that's off on that. It's off by like a little bit, too. Let's figure out what that error is. So I got to go back to that part. I'm going to hit save. Save. Go back to the part. Motor mountain. Okay, so that is based on the first sketch. Numero 1. And if I move it, everything else will move with it. So that height, 8.5, is wrong. And now we need to reevaluate what that height is. Unless some other thing is wrong, which is, very possible. It's very possible that I got a lot of stuff wrong. This would be a 5mm cycle. Yeah, there it is. 4.98. So it's 2.5 above the lowest point in this direction. So I'm getting 5.6. I put the height as 8.5. 5, 6, 7. 5, 6, 7, 8. So 5.6 plus 2.5. 8.1, right? And it's at 8.5. So let's change this to 8.1 off of the very, very specific measurements. And that bumps it down. Finish the sketch, and it runs through the algorithm, and everything fixes itself. And I hit save. And then this one goes, holy shit, something's different. And I go, yeah, man, everything changes. And I hit get latest version. And then my hole goes, and it's a little closer to center. I mean, we could probably measure it and see exactly where it's supposed to be according to my models. We are 1 millimeter. Which one is 1 millimeter? Which one's off by exactly 0.1? Which direction do we need to go? This one. So the other hole needs to move. Huh? That arrow is based on this point, and it goes up to the center. So our hole needs to move down by 0.1. What up, Demi? How's it going? How it go? Sketch 1. So is it, what is it, just 8? It's just 8. That's a nice round number. How did that happen? Finish. I want a Danish button. And like a Danish will drop down from the ceiling. And then I'll eat it. It'll be delicious. Bonk. Update. Get latest version. Drink seltzer water. So now if I measure it, these should be dead on. Look at you. Dead on. Yeah. Okay, cool. We fixed it in situ. I probably could have actually edited the component in place and done that. How do you pronounce the A with the dot over it? The A with the like ah? Is it Ostbagar? Ostbagar. The thing is, the problem with doing this whole extensive model build that I've been doing and 3D modeling it, is that 3D modeling wants it to be perfect, and it's not perfect. There's an error. Nobody is building these carbon fiber parts right because their machining has probably slipped. So the holes, I believe, that are, yeah, right here, are a little bit too far this way. You can see it too. And this is something that really, really frustrated me. That has a nice round outer radius, right? That one tapers in and then back out. These are in the wrong location. So frustrating. It makes it so that the pan in this model is just a little bit bowed downwards, which is not a big deal to me, but mouth should form an O. Bo. That would make that Bogar. Bogar. Bo. Okay, let's see. What's the next step? Sorry, my brain has been leaking out of my head this entire stream. And now it's just finally come to pass that I no longer have my full mental faculties. This is coming together good, though. I should have made the motor orange, because my motor is orange. The orange motor is way too much. The actual, like the black motor for the FR, or whatever, the Rocket RC, is probably a good power level to have in this cart, because the 9500 kilovolt is so fast that I do not get to top speed. 3D printed instead for accuracy, but the top bar is a rigidity thing. It needs to be in carbon fiber or metal. The metal one is in the right place. If I had a CNC, I would love to actually print it, but the idea of a guy screaming "ah" with the face of a PogChamp is killing me. Boah. Okay, I'm done with that. The dumb shit that I do for you guys. Okay. Build an MPCNC. I think I have enough parts around the shop. I actually do think that I have enough parts around the shop to build a CNC. I would love to do that. Look at all this time that I have, though. I just can't even hold on to all this time. I don't have time. I have a frame that was for the upgrade to burn the subs that never came to fruition. You know, sometimes stuff doesn't work out, and so the upgrades to burn the subs didn't quite work out. So I have a nice frame that I can, and all the motion stuff that we can make into a mini router CNC. I even have a router. I bought a router in order to make the drain on the table, and I cocked it up really bad. It's like really, I did a really bad job. I really wish I used more care to put the stops in and everything, but mostly printed CNC. Well, I mean, we could make our own. We're gonna make our own thing. I don't wanna follow somebody else's thing. I don't think I have the proper bearing. Let's look at the bearings in here. I have to poop. Well, I'll wait. RC car projects, generic parts would probably be bearings. Yeah. I only have one bearing overall. I guess it's okay if it's kind of the wrong bearing. Okay, well, whatever. This has 3D printed shocks. I was thinking about trying those out. Relying on the 3D print to bend. Okay, let's put the bearing in. There he is. Waiting, watching. CNC like to have it full metal so it won't tamper with measurements due to flexing. I think they take care about that sort of thing in the mostly printed CNC. Because like if you properly support your 3D prints, they're pretty nice. There are balls in this ball bearing. Are you kidding me? Sometimes you get a model and it's just way too detailed for your own purposes. Bonk. Yeah, it's not quite the right thing, but it represents the right thing. I don't know. I think we couldn't find a bearing that was exactly the right size, so I just kind of threw that thing in there. Yeah, having its own space would be kind of important. Wait, what is this step? Oops. Delete. There we go. I accidentally double moved. All right, next would be this gear. And I'm taking it, yeah, this guy right here. And we're taking our point to be the outer radius, and I'm taking it to exactly on top of the bearing, and then I'll see if it needs adjustment from there. So I'll go to this face right here. I think that's actually colliding with the bearing a little bit. But what I could do is just move it out this way. Let's capture the position before we forget. I'll just approximately put it right there. And then tilt on this axis. I gotta move the motor too. So actually, let's wait to do that. And then I'll do, okay, let's see here. So I've got to select both of these at the same time and make them move properly. So we need to find this on the tree. We got to do it from the tree. Well, actually, that motor, I can select the motor, which is all the way at the bottom, and I click move. And then I'm going to click the generic move, and I have one selected. Let me control and select the other one. So now we have two selected. That'll move in tandem. Where are my axes? Well, what I can do now is select, and here's the trick. In order to get those axes back and have them aligned with X, Y, Z, what I need to do, what's that? Did I forget to click? Yeah, I did. Boop. What's going on? 227 components, our new winner. This thing? Why is it so many? I have little faith. It's yeah. I do mostly soft. I remember learning how to program a CNC, and all we had to look at was a very blue screen with yellow text. Yeah, the old stuff is crazy. Full metal, so it won't tamper with the measurements due to flexing. What's the wait? What's the yeah he did? Didn't Fat make one of these? Oh, yeah. The thing about the CNC that I would be able to make is that it would be made out of putty. It would be made out of gum. No, it would be made out of, made with Delrin rollers, which wear, and then it would get less accurate as it wore. I do have some leftover rails, actually, so maybe we could do rails. It's just I bought all that V-slot extrusion. You kind of want to use the V-slot extrusion, except I don't trust rollers anymore. I've got all this I've got like tons of roller hardware that would be perfectly fine to use, although it eventually goes all stupid on you. Okay, move copy. Sorry, I got to concentrate a little bit. Capture the position, select the extra one. So that one says 2 components, not quite as... But now, okay, so if I want to re-center those generic moves, what I need to do is move to another step and then move back to this step. And then it chooses kind of the center of everything for that, for that little like movement grabby thingy. If I select the origin or whatever the hell this move is, it doesn't allow you to select multiple. So that will deselect the other ones. So you got to be careful about that. This is one of the weird tricks about moving stuff in Fusion. Why are you there? What is going on? Why are you there? I guess the motor model is a little bit cursed. That sort of doesn't really help me at all. Oh God, everything is crazy. Let me just select like that. There we go. Hello? What? Why? All right. So it's having trouble reconciling the move. We can go back to the step where I move this. So if I click on it and then look at the timeline, holy shit, the timeline on this thing. Let's go back to wherever this stuff goes into place. That would be, what is happening on this one? I think this one's doing both the sneaking it backwards and that. I think that should be sustained. So there's this move, and I think that might be the twist of the motor. That's the position of the motor. Okay, so let's select this. Move. Did I select it? No. And that's going to be like, so if I select it there, and then I do this, why is it all the way over there? Well, I think that axis is X, isn't it? -2. 2 is too far. I don't really know if 2 is too far. We'll try 2 and just see if they are totally separate from one another. But maybe we'll just do it -1. -1. That puts it in the center. So click OK on that, and then repeat all these steps. Oh, finish position. Sorry. Yeah, and then it takes us back to modern times. Yeah, it does. It looks like it has to go to 2. So where was that step? That one was, oh boy, where the hell, where are we going? Come on, double click. Help me out here. There we go. Move this thing. I'm assuming that it's going to be on the x-axis. So -2. Okay. Was this after the turn? This is after the turn. Let's get out of here. We want, before we spin it, when you spin stuff in Fusion, everything like gets chucked out of the window. It's a very traumatizing thing for the CAD software. I've had a lot of trouble with stuff that's been twisted. A lot of torsion. So that'll be another -1. There we go. Now we're all the way to the right. Finish. Those still don't look like they'll mesh. Jeez. Oh, wait, it's moving back. What the? Did the rotation really mess it up that much that when it rotates, it captures it at that position? Oh my God, that is obnoxious. So because I rotated it as a separate step, what's happening is it's rotating and moving back. So I need to somehow move it 0.1 to the right. Okay, so we need to move it in this step, not the previous one. This step is where it needs to move. And I need to move it 0.2 to the right. So modify the motor, or sorry, move, not modify, move the motor. I mean, I guess I can do component XYZ, the design XYZ, and do -2. There we go. That's how to do it. -1.8. Just so we're not totally representing something that can't exist in the real world. I don't want clipping. That looks like it's offset. Why is that offset? Oh, I guess it needs to move forward a little bit too. Because it went center on those. So the motor really should be up against that plate. So what is that? Is that Y distance? And if I move it 2, 1, there. Not quite touching, but I guess I could do 1.2. 1.2. Is that clipping? A little bit of space there. 1.1, I guess. 1.1. There, just a little tiny bit of wiggle room in there. There we go. Okay, so finish the position. You bastard. You bastard of a gear. Where's your locked position? There. Now that should be moved in the right spot on that. Yeah, good. Okay, so, God, this is annoying. This is just one of those things, huh? Okay, so here it's got like a cursed orientation. So if I take it over to point and then take it back, now I can move it on the cardinal XYZ And now I can do that, and then I can take a point to point. There might be a further step where this thing is scooched inwards. That went to the wrong one, didn't it? Yes, it did. Bonk. There. And now this. Take it back in. So the question is that going to stick? That's not quite in the right position, but now I can finish position, and we can see it go right back to where it was because I had the audacity to touch it in a later state. Let's go ahead and leave it there. Leaving it there, that's pointless. All of that's pointless that I just did. So we got to find the step where I touched it, which is this one. Now I need to move it over. I should probably fix it for all the other steps, but can I like deselect it? No. Modify. We're going to move you again, but on the cardinal direction. I'm going to move it away so I can get to the points, and then I'm going to go point to point, and we'll go from the end actually to this end. Centered. Why can I see through that? Wait, why can I see through that? That's strange. I guess I was just looking through the one little hole for the slot there. Okay, so now I'm going to scooch it back. Actually, I think I scooch it. This was the step where I scooch it back. Yeah, so I need to do that. So I need to do a move like that. There's so many points on this thing. There, just get it close. Okay, I fixed it. I fixed it. I fixed it. They don't mesh. I need to go back the other direction. I hate how the moves aren't based on the points that I'm clicking. I should be able to move the motor and have this thing move with it. I need to put it at 1 millimeter, not 2. I mean, I guess I can check the distance between here and that doesn't really work because it's on a rotational axis. It's going to bug me forever if this is like this. Damn it. I got to go back. I mean, I could also move it in this step. I could just select the motor with everything else and just move it barely in. In fact, I think that's what I'm going to do. I'm going to take this step to just correct everything. But then, will that look good in the animation? Probably not. It's not really an animation. It's just me running through all the steps. Let's just see what we have so far, what it looks like from here. Boop, 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 boop. Entering the parts is a very difficult thing. I wish you could have it sweep around while the parts are going in. I think that's more for the animate functions that I don't know how to use. Probably should have started it from... I think that's what these are for. You guys, could you guys hear that? Yeah, she's going nuts at something. Hurry up and build this thing, jeez. Huh? Oh, damn it. I had it stop there. Well, now I got to do it by just advancing this thing. So, boop, boop, boop. Oh my God, Willow. So I guess, yeah, at this step, I'll just twist it. Or I could twist it when I pull in the other gear. That's probably the better place to do it. Sort of like that, and then this. You know what? I'll just make that its own step. So this step right now will be me putting it into position. I'm getting a sore throat. I don't think I'm streaming tomorrow. I'd love to do games tomorrow, but I wanted to do another game stream because they're very easy to upload. But my throat is getting a little bit sore. I hope I'm not getting sick. I don't think I'm getting sick. All right, so what I'm going to do is I'm going to move the pinion gear. Move tool. Ah! Why is it so many points to select? It's so weird. I'm going to twist it on this axis. 10, 11, 12 degrees. There we go. The animation motion section of Fusion may have its own assembly constraint. Other CAD I've used does, specifically for shit like gear. There's a lot of tutorials that I need to go through in order to learn how to use that. I've never used it before, so yeah, I assume that I would be able to put this stuff together and have it like rotate around and do cool stuff. So in that step, well, I guess I'll use, yeah, we're at a good position on the gears. I just need to move it over a little bit, and I'll do another move step for that. So we'll do the rocket, and which one is this? Spur gear. And I'll just sneak it in a little bit. Why do you torture me like this? I can't. If I click here, will it? Okay, it'll allow that. So then the X distance based on the design's XYZ is negative 0.5. Bonk. Negative 1. Why does it look like it moved so far away? Huh. Oh, because it did move away. 2. 1. 0.5. What? Why did that move it back over? What the heck? Wait. 0. 0.5. 0.4 rather. That's good enough for my purposes. I don't think it's clipping. It might be. Capture that. What are you guys saying? You can define motion links that would control how those two gears drive each other. You just specify a multiplier for how fast they turn relative to each other, rather than actually modeling the gears meshing. I was thinking about that, like all the collision stuff that happens. I guess you would want to set your constraints to be, because this is like this is not. I don't need to know like the amount of force that the gears are putting into each other. I don't need to model that specifically. Or you have very complicated interactions on like the curved surfaces of the gears that you just don't need necessarily. So yeah, I guess you would use all those constraints in order to put it in. I tried doing a little bit of like motion constraints and stuff that would allow me to like put the things together and have like the gear, the steering work or something like that. It was on a different model. I think it was Tom Thinks's button that I wanted to do. Yeah, we did the motion on Tom Thinks's button, but it was like setting those constraints and stuff it was so difficult. And when I figured it out, I don't know why it worked. But yeah, because then you can have your model and you can just click on the steering and move it back and forth, and all the stuff will move with it. It's really cool, but I don't know how to do it. I don't know how to do it. I know the principles, but don't know how to do it. Okay, we're almost there. Move. What time is it? Ah, it's not bad. That's not that bad. We might make it through this point to point. And we're going with the rear. So this point goes in. Wait, is this the rear? It is. It is. Spoilers, it's the rear. Oh, I messed this up. Uh-oh. Oh boy, that's a thing. I'll unfuck this in a little bit. It's that's the wrong position. That's the wrong position. That's why it was so constrained. So we're actually going here with this one, and I'll fix the other one in a minute. I'll fix it as its own step. I figured that's the easiest way to do it. What just, oh, now I can't select the component. Ah, man, move this, capture the position, point to point, this point right here to the closer one. There we go. Bada bing. Okay. So we've captured that whole thing. Of course, the drive shaft is going to have to be slightly moved. But before we do that, I will assemble the entire, we'll basically finish, and then I'll sneak the front up a little bit. This would be the minimum wheelbase, which you can't actually do on this model. This right here, capture, point here to point here. I still remember it's 0.35 for the 3D print part, and these are -10 degrees. Move this thing, whatever the hell that thing is, disgusting, from not that position. From here. I wish it was easier to set up the constraints and stuff on the moving parts, because it would be really cool to be able to do on this model. Here, and then we're going there, capture, okay, and then we do the other one. Sometimes the view is just so hard to wrangle. From there, capture, this is going to be a struggle. No, actually, this is fine. Whatever Fusion is doing in the background to figure out where you want your view anchored works flawlessly most of the time. It's actually really, really good at figuring out what you want to, like where you want to pivot from. And I don't know what coding went into it, but they did do a very good job of it. It's just sometimes it gets frustrating. -0.35. Move this whole thing, this whole nonsense here, from, come on, give me the thing, there it is, back over to here, to here. Good. Capture. See, this is where it's doing it. You can see all this mouse movement is barely moving anything because it's looking like way off into the distance and it can't really figure out what I want to center on. So if I mouse over this and try to move it, I'm now on that. It thinks that you're trying to do something 5,000 miles away. So we want this and our first point. Oh yeah, here, first point, capture here, come back over here. Usually I would do this all in one big capture position step, but this is its own model, and it's possible that I can use the assembling process as an animation. That would look really good on video. Come on, buddy. There we go. And we're moving it to there. Okay, capture. Oh man, this is a lot of work. This model has been obnoxious. We didn't even get to any of the designing stuff. So I guess we're going to do that next time. We'll set up the new file and everything too, and we'll watch the animation. All right, and then this thing, twist it here, 10. Do we do individual steps for the two? I guess I probably did. So move, more frames better. Frames good, we like frames. We don't like interpolated frames, and we also don't understand how nobody sees how awful interpolated frames are. I don't understand how people can be okay with their TVs looking like that. We're not twisting. We're not twisting. We're going point to point. From there, and we are also capturing it to here. What I hate is that TVs turn all that stuff back on too. And every single smart TV that I've ever used has been just begging for the sweet release of death. None of the OSs work properly. New file, you and your no editable file limits. Yeah, sorry. I would have a huge archive of stuff if I didn't have the educational copy. Huge archive. It's nice that I don't have to do it. Now, you can do like multiple parts in a file. That's actually what a lot of people do. You put your multiple, like you have a parts file that would basically have been all of these parts like strewn all over the place. That's essentially what I'm setting up, I guess. Solid Edge has no limits and it's all locally saved. At some point, I do need to go through Fusion and export everything and then put all the step files and stuff on GitHub so that, you know, they're shareable. Because Shorty and I tried to do the file sharing thing and it wasn't exactly intuitive. Look at that frame. Beautiful. Now we can put the wheels and the crossbeam on. Let's do the crossbeam first. Move this thing. And we are going to twist it, actually. Yoink. And then point to point. I'm going to go from the bottom of this thing to the top of this thing. As soon as we get there. Ah, cursed. Looking good. Hell yeah. All right, let's get this stuff in here. Oh, where is the center point of this thing? Oh boy. How do we... Chad, I have no idea how to do this. It's funny though, I can't enable the wheels and have that capture as a thing, can I? Maybe I'll do that as the last step and we'll see how that goes. So point to point on the selected component, origin point, there is a center. Oh, thank goodness. That's very helpful. That's very helpful. Because that center will be even with the bearing that I would have installed in this thing if I had any. I guess those bearings that I pulled in were the wheel bearings. But we don't really need the wheel bearings to be represented in this. Capture position, this object. Select the point. Center. Target. Acquired. God, that's hard to get to. All right, and we go over to this side. These are like 1,000 miles away. Okay, just, you know, get right in the way there. There we go. So move this thing, select the point, capture the position. Oh God, I hope I clicked the right point. There's like 1 billion points there. The zoom is still on like 500 miles away mode, so it's like, there we go. All right, come on, hurry up. Move this one. Capture the position. Choose the middle. Slow moving, slow zooming. My finger is gonna fall off and get like some kind of a sports injury from that. Okay, one last thing to do. That's to move the front forward just a little bit. And I still need to make the parts for the rear linkage because they're gonna be at funny angles. So I need to select all of the stuff in the front. I guess I need to do that just with the control key, huh? This is going to be obnoxious. We got to go through the whole list of stuff, huh? So that's one of them. That's another one. Nope. I got to hold down control. Nope. Yes. Yes. Which one is that? Spring pin? I gotta look at the whole model at once just to make sure that I'm looking at the right stuff. Yeah, so not that. We want that. Not that. Which one is that? Nope. Yes. Yes. And then I want that one. That one. I do actually think that that was a wheel bearing that I maybe need to bring. I should have probably brought in more of them and put them in position. I was bringing them in as wheel bearings actually, and they were the wrong size, I thought. I think that was actually the case here. Okay, I want that one. That one. Yeah, and the wheels. I think that's everything. So now we need to move it to a point that I don't have access to. Well, okay, click move, and then we'll free move it. Oh, I didn't get the spring either. Uh-oh, uh-oh. If I hit cancel, is it going to deselect all this stuff? I can get the spring from here. Okay. Where is that one? I want that one. And then this one. Okay, I think that's all my components, right? Why are the wheels not moved with the actual wheels? Oh, that's going to be very annoying to fix. That's going to be very annoying to fix. Maybe I can rewind time and then show the wheels. And no, but they won't travel with it because if they're not seen, they're not shown. That's such a weird thing that this does. Okay, so what I'm going to do is I'm going to move this stuff off. Yoink. It's like a comedy bit. And then, yeah, because like, see that the unseen pin isn't moving with it either. And I guess that's the way that people have been doing the whole file shenanigans, the file limit shenanigans, is you can individually move components that come from one drawing. There, that's the right position. Okay. And then capture that. So with the wheels, getting the rubber to be visible on the wheels is going to be difficult because they didn't move with everything else. So I guess I can just I can go to the Volvo wheels. Actually, what I can do is I can go and enable it in the other file, and then there will be, the tires will always be there. Or maybe I could do it from here. If I do it from here, I don't know if it's going to be visible on the timeline. Let's just try it. Let's try it. Wheel. Volvo R bodies, tire. Oh, it did follow. I wonder if that means they're going to be there the whole time, or if I need to like move something and then they'll appear. Oops. Bonk. 3 out of 4 is enough, right? Keep clicking on the wrong thing. This is me being mentally tired after today. There it is. So this is as far, well, except for the linkage in the back, pretty much the RC car. Uh-oh. I hit Control, oh, I hit Control Z. Control S. I'm not going to be able to sleep at night until I make that linkage, am I? Did you hear that? Hello, you're ruining my stream. So I'm going to rewind all the way back to when I'm inserting components. See, the thing is, I have it as its own, like, thing. If I do like an XYZ, I guess I could put it in the right place. Let's try that. So if I go from here to, oh, but I don't know where the point is on there because I didn't model the three holes on this thing. So it would have to just kind of get to this plane. If I could define that as a plane and then this is a plane, how would I do that? It might be better if I just build it in this thing. I don't know exactly how I'm supposed to do this. This is like tough. And then I could use like mirror tools and stuff in order to actually create that part, but I could create it on the other model and then export it to a part and then just magically import the part into this thing. Do it for accuracy. Where's the other model? Because yeah, this is now my uneditable. Add reference planes inside parts to use as assembly constraints. Huh. I can't even approach that sentence. I don't know what that means. Interesting. So you would, in Fusion, you can make assembly constraint like axes and stuff like that. It's an entire, the construct menu is pretty much, I think, what you're describing. And that gives you the ability to like put stuff on stuff. I'm just going to do something that's totally cursed, and I'm going to take this and put a move copy on it and move it to the rear. Create copy. And that's going not to where I put it there, because that, I think that was a result of me measuring the wheelbase, but I'm going to put it here. Oh, but then I need to move all this stuff in. I didn't, this is at the maximum. Yeah, I need to move that in. Oh boy. Okay, so we got to do that game again. God, it might be faster for me to do this by selecting it all and then deselecting stuff. I guess I could do it and not save the drawing, but how does a battery have that much room when my battery barely fits? That's weird. There's so much more. Come on. This one, that one. There's so much stuff. Oh, geez. Where's the housing? There it is. Having this as like a sub-assembly would probably be a better idea, but we don't have those here. We're not burdened by better ideas. Is that everybody? Looks like it is. This is the old cursed drawing, so I'm not too broken up about making it even more cursed. From there to, it's 1, 2, pinhole, pinhole. And we want it to be in the restricted. Oh, God damn it. Hold on a minute. We got to choose the right side. It'd be like me building at IRL. There we go. All right, cool. Now I'm going to bring in, this is just like we're just going to ruin this freaking drawing because we have the other one now that's more accurate and doesn't have the 3D printed stuff on it. I will never put a fixed DC brushed motor like this, not fixed, a brushed DC motor into this. Okay, so now I'm going to go to my generic parts and I'm going to bring in not the fitted, the filed one. I'm going to bring in one of these with the little tab on it. Bring that all the way over here. Click OK. And then bring in one of these. Bring that all the way over here. Click OK. I'll capture the position just to cover our tracks. And then we're going to do another move on this, and we're going to put these both into position. I've always seen that generic motor. Are there better motors the same size? Yeah, you can do like a Tamiya dash motor, the plasma dash. It's this is like, this thing is crazy. You're supposed to change the brushes out each time you use it. But there's a whole like category of Tamiya motors that are like slightly more badass versions of that fixed DC motor. One of them even exploded when with an original version of this RC car. But they've got like bigger wire on the coils, and they ruin AA batteries with wanton abandon. Or you can go 3-phase. You need a new motor controller for it. But this fits into the bolt holes of a normal DC motor. Although a lot of them don't have screw holes in the front. I had to drill some of my own when we were playing around with this model kit. So I mean, this thing is built for a slightly different design of motors. There's a slightly more powerful version of these that are a little bit, yeah, I know, wontons are delicious and they should never be abandoned, where it has screw holes in the front, and it's a slightly more powerful motor, slightly higher voltage, I think. But yeah, there are different versions. Okay, so let me move this thing, and I'm going to take it from a point to point, and I'm going to select the rings. Listen, there are probably better ways to do what I'm doing. I don't know them. And unfortunately, learning them on stream is a little bit of a cursed thing. Yeah, check it out. There's all kinds of cool motors out there. So how do I do the position of these two things? I mean, they are a certain distance from the edge. I really should have modeled those holes, shouldn't I have? I still could, I guess. But they're 8.25 from the edge. Where would I measure from? I could do a sketch just to position these. Because I won't need it in the, oh geez, capture position. And then I'm just going to do, I'll actually do, maybe I should do just a regular box. But if I go from that corner in, then the position of the holes, well, it says 3.1, but I'm going to go 3 by, I want to say 7.6, but that's not quite right. Three by 8. Let's try the even numbers. So that one is 8. This one is 3. So now that I have that, I can move this one, and I can flip it like, wait, that was the axis I needed to flip. I need like this and like this, and then I can do. Unfortunately, I don't have the locked down context of this being a ball joint, so I don't really know how I'm going to accomplish moving that. It's from here to that point. How do I get two pieces to face each other? That's a weird one. Because now I got to go into the parts that I've put in, capture that position. And I need the two ball joints to face each other, because that's how this linkage works. It just keeps the suspension from torque steering, or what, bump steering rather, from bump steering. Take that one, take the body, take body 2. What I want it to do is I want it to face that one. I can look at the difference between the two and maybe figure out some math, try to make them align with one another. Is there a way to align construction axes? Axis perpendicular. So I could go in and make axes that go through these, but parallel on the flat face. Align. I wonder what if align would do that, or arrange. Simplify, no. Remove features, huh? So if I select both of these, I wonder if I can do an align on them. You do the other ball joint. Oh, well, it's okay. It's still right there. Bodies, and so this one, and this one. See, they don't know that they are constrained, though. They don't have that constraint. If I align them, it's just going to like rearrange them. Yeah. I've done it. I've aligned them. Cancel. I guess I can eyeball it until it looks close and then try to... How would that work? It has to be a series of rotates from the center position of this barrel here, this part. I need to basically have it rotate around that. Let's see if I can figure this out. So body 2, move. I need just this. It doesn't let me do it. If I do components, then I can't, it'll move the whole thing, I think. Yeah, it's moving everything. I think I'd have to do like a ball joint constraint on it. That's tough to do. Yeah, I don't know exactly how I'd do that. Which one needs updating? I think the way that I would be able to do this in sort of my own context is by... Well, so I need those 2 points in a new... This is where you should be making each thing their own component and subcomponent if you want to do joints and stuff in the future. Yeah. Component and subcomponent. That's like a whole thing that I don't know about. That's a whole thing I don't know about. So the problem is I don't know the distance here, right? I could make a bar and then make this component with a bar in it, and then I could try to like... I mean, what will we do? Let's see. Okay, sorry. I'm discombobulated because I don't know what I'm doing here. That's the thick of it, is I just don't know what I'm doing. So if we made this into a joint, motion link, contact sets, motion study. It's not really that. I don't totally think of it as that. Its own thing. If I do a subassembly of the 2 components, the problem is I don't know the distance between the ends of the 2. So I don't know. I'll have to think about this. I'll have to think about how I want to go about solving this problem. I was going to use this model as my cursed, sort of the model that you leave behind in the whole scheme of things. Like, yeah, thanks for your help, asshole, as you jump off of Yoshi's back. But I can't get the movement that I want out of these ball joints. I could make a new model and I could dead reckon the angle and the up and down and stuff, but that's not really going to get me there. You only need to learn how to appropriately constrain things. You have to work around this artificial part limit. I don't have to do that. But yeah, people do. All right, so I'm going to leave that linkage as it is. Let's just take a look at the other animation. I'm actually going to save this one just in case I want to come back to it. This design is getting more and more cursed as time goes on. But yeah, this new one with all this crap, look at all these parts, ready to be worked on. So when we come back to this, and hopefully the next stream we come back to it, we are going to be concentrating on this area here. this sort of tucked under the bar area. And we're starting at a nice little location. So our 3D print can pretty much just flatly go out into this area over the drive shaft. So we can make a whole complex that will house all of the electronics. Not necessarily, you know, it's going to be a big open thing. It'll just be like press fit electronics, but that means that when this thing at 110 miles an hour goes straight into a curb, it won't send electronics all over the planet. So teapot as case mod. What are you talking about? What does it mean? Who are you working for? Let's just see what it looks like. Let's see the whole animation. I wish I could collapse this stupid thing. Oh, I can. There we go. Boy, I was used to working kind of discombobulated. Oh, a teapot for the... That's right, you're talking about the teapot racing. Could you imagine this thing as a teapot racer? If I could find like a little teapot that's like just the right size, and then I could put 2 posts that would have magnets on them, and just clink, the whole thing would go together, and then it would be the absolute most ridiculous, overdone teapot racer in existence. I think part of the teapot racer is that you're just supposed to go to a toy store and get like a really crappy toy car that's not necessarily fast, because you have to go around obstacles, which you could fake it with this thing if you really exponentially limit your throttle, but then all of a sudden you could burst out of like at like 1,000 miles an hour. That would be pretty funny. What happened to this? What's going on there? Oh, that's just it's just the geometry. All right, so let's see what the animation of this thing going together looks like. We're being like totally extra, right? Like I don't need to do all this. I think this is a fun stream to kind of explore what I know about CAD, and now I know what I don't know, which is all of the sort of assembly, like limits of ball joints and stuff. I need to learn how to do that because I need to go back into those models and define those constraints so that I can go to this model and just click on it and it'll move around, right? I think that would be fairly useful to do for this. And, you know, you could see the suspension working and stuff like that. That would be very, very interesting to do. I don't know how to do it, and it would take a lot of time. Let's take a look at this. Animation panel and the auto exploding thing. I don't see that panel. I ain't see no panel. Oh, it looks like the rubber's in there the whole time. Ah. Whoopsie daisy. Click on design. Okay, give me a sec. I just want to see this. I wish this could do like rotating around it, but maybe it can. Maybe we should look at the animation panel. This whole stream, all 4 hours of me like noodling around with this thing, and it's probably going to be 2 button clicks in order to make the animation panel do it. Okay, so design. Hmm. "3D print? What does that do?" Oh, that's just the export. Okay, let's see. Surface mesh, sheet metal, plastic, utilities, inspect, utility. Oh, design. Oh, look at that. Hold on. I think I actually have access to the generative design stuff, but let's see. Render, animation. Whoa. This is an ortho. Why would you do this? There we go. Transform. Auto explode all levels. Oh. What do you mean no available? Oh, this is going to blow up my computer, isn't it? Show hide, appearance, restore home, transform components, auto explode on all levels. No survivors. Oh boy. Here it goes, using all of my computer cycles. Oh boy, I've been given unrestricted access. Luckily, we water cooled this computer, but the water is boiling right now, so that should be fine. It's in a super state. Am I dropping frame? I'm not dropping frames. That's usually the last indicator that something's gone horribly wrong. It's like, there's a lot of stuff here. It might, is it going to explode the motor and stuff? I think it will. I think one level was probably what I should have chosen. Boiling water like in a teapot. You just won't drop that, will you? Oh boy. Oh yeah, I have these wheels behind me too. Doot, 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 doot. Yeah, these are looking good. Short Lurker, was it you that told me, because I was talking about this earlier, that the 3D printed wheels are banned in some race? We were wondering why. Why would they be banned? Ooh, wow, that is a horrible print. That looks like it's absolutely terrible on the inside. Wow. I don't know if they'll even bolt to the hubs. The standoff distance for my support material is extreme. Oh, look at that. Here we are. So can I, if I deselect them, will it? Me when I hit the curb. Me when I hit a small rock. Yeah, I don't know. Could be for safety reasons, because we were seeing a lot of articles about RC car stuff being totally printable and awesome. So I can animate stuff using. How do we do that? Yeah, I'll have to figure out how to do this. How do I sweep from one to the other? That's, you know, that's just what's going to happen. This is complicated and it's really, really powerful. Feel free to add me if you got any questions. Yeah. Man, that's crazy. See, what I want is for the camera to spin around as this thing assembles. That was what I... The motor blew up. That's what I get for choosing all levels. It's anything that's multiple components is also exploding. Yeah. All those parts that like were hard to move around have separated out. Now I know what it'll look like when I reach the top speed. But I have no idea how to do anything else in this. Storyboard. Yeah, I guess you'd use it like video editing. View is not recording. Huh. Strange. I'll have to learn this, but that's cool. I have to learn like the generative design and some of the other stuff because I think there's a lot of really cool things to see with Fusion that I happen to have access to. I don't know how to unexplode you. All right, let's go. Let's just go back to design. I don't want to curse this file before it's gotten the chance to run, because this is now the untouchable baseline of this RC model, and so we'll come back to this and we'll design, we'll position all of the electronics, and then I'll try to make it so that they sort of snap into something that'll maybe have consideration for the wiring if I can manage it. Maybe not, I don't know. But thank you, everybody. Thank you for joining me on this Friday. We have very few people. Apparently there must be something cool going on, but I will catch you guys around the internet. I don't know if I'm going to be streaming on Saturday. We'll see if I'm up to it, because my throat is getting a little scratchy. But yeah, the video uploads will continue on this on the YouTube channel, which has nobody. And well, one person keeps liking my stuff, so I'm happy with that. But yeah, we'll get back to stuff and we'll just keep trucking. We have synthesizer stuff to do. I have Burn the Subs to do, obviously. And yeah, I hope to get back to that. And I bought this expensive oscilloscope, this awesome new Rigol, and I haven't had much of a chance to use it outside of audio projects, which is kind of a crime. That's kind of a crime. So we'll get to this stuff, and I will catch you guys on Discord. I might continue to design the electronics in this thing, and we can kind of learn. I can hopefully read ahead and maybe learn how to do some cool animation stuff, and maybe do some of the linkages so that this thing is a little bit more natural. Like, I should be able to grab this and like turn it, and it should be locked in place. What happened to the synth stuff? It's just over there. I'm just frustrated. You can see it right there. I am just frustrated at my inability to get the VCOs running. They're analog VCOs, and there's a lot of tweaking to do to get those things working. The two other ones that I have aren't functioning, and I can't make like multiple harmony things. And if SpeedyCat ever sends me a package, I'll have a lot more synth stuff to build. In addition to that, we also have the super cheap synth stuff to build out of the ESP32s. And since these are using a digital to analog converter, I know they'll work. unlike the analog stuff that just continually disappoints me. So yeah, there's much more audio project to do. But anyway, I gotta go. I got a sore throat. So I'm gonna go drink stuff, and then I probably... Nah, that wasn't a very good joke. I'm not gonna do that joke where I cut it off early. I'm just gonna end the stream. Have a good weekend, everybody, and I'll catch you on Discord. Oh yeah, here's the end card. End card. Sorry, the farts aren't working. I probably have to re-up the, whatever it is, the secret code. So, all right. Why did Short Lurker... Oh, because it was a fart redemption. Yeah, all right. There's no guarantees on the farts. You're not guaranteed to always get a fart. You know? Never trust a fart.